Hi, everyone. We'll get going in just a second here. Thank you so much for joining us today. We are at the annual On-Farm Applied Research Forum. Sorry, hold on one second. And we have an action-packed half day scheduled for you. I'm going to start with a land acknowledgement, and then we will get right into our program. We acknowledge that we are on the traditional territories of Indigenous people, including First Nations, Métis, and Inuit, who have cared for these lands and waters since time immemorial. We recognize the deep relationship Indigenous people have with the land, grounded in respect, knowledge, and stewardship passed down through generations, and we offer our gratitude for their care of these landscapes and for the teachings that continue to shape how we think about agriculture, soil, and water today. We are committed to listening, learning, and moving forward with respect. Thanks so much. I am Kelly Carmichael. I am the Knowledge Mobilization Specialist with the On-Farm program and with the Living Lab Ontario program. This is our annual On-Farm Research Forum where we update you on all of the findings that continue to go on with the program, and we have a lot of great speakers to share with you today. I have a few housekeeping comments first. Let me just see if I can put this back. Yeah. So in the chat, I have added a link to the information package that I had sent everybody yesterday. There's a few updates to the information package, so I invite everybody to download this most recent package that sits up on our server. As I mentioned earlier, we have an action-packed agenda. So the information package will provide you with speaker information, bios, and more in-depth information on our program today. So as we go through and I introduce people, I will not go through all of the bios. You will have all of that information on hand as we go through. I invite everybody to introduce yourself in the chat and to add questions in the Q&A. And if you go to the bottom where the three little dots are, if you click on that, you can see the Q&A link, and the chat should be on that bar as well. And please introduce yourselves. We hope to have lots of questions for our panelists, and we're really looking forward to your interaction today. At 10:30, we'll have a short break. It'll be for 15 minutes. We'll just turn off our screens here, and we will come back at 10:45. So just to know that that will be going on. After the forum, I will share a survey with you. I really hope that people will take the time to fill it out. It's only a couple questions, but it helps us create a better forum every year and give you the information that you're looking for. Anyone that is looking for some off-CAF knowledge sharing credits, KSEs, I will share a QR code at the end of the day, at the end of the forum, because this is KSE for nitrogen management, and you will be able to access that KSE as well. Now let me just, okay, I'm looking at our panelists. We are waiting for our first speaker, but that's okay. We're going to keep going, and I am going to invite up Nicole McKellar, who is the Director of Member Services and Business Development for the Ontario Soil and Crop Improvement Association, where she will open this event for us and share a few remarks. Thanks, Nicole.
Right. Thank you very much, Kelly, for that introduction, and good morning to everyone. We really appreciate you taking the time to be here with you today. It's absolutely my pleasure to be here with you and to welcome you to the On-Farm Research Forum. I first off just want to say thank you to OMAFA, our funding partner for this program, to our farmer cooperators, our researchers, conservation authorities, and all of the staff at OSCIA who continue to make this program program such a strong example of collaboration in action. It's been another busy and productive year for the On-Farm program, and I just wanted to take a few minutes to highlight some of the key activities and accomplishments that have occurred over the past year. As many of you experienced firsthand, dry conditions across several regions during the growing season did result in reduced edge of field sampling. Despite this, though, the conservation authorities have made significant progress in strengthening their monitoring capacity and preparing the sites for the major winter runoff events that have occurred. And I know all of us across the province have experienced quite a few of those already over the last few months. At our North Kettle site, new water level sensors and water flow meters were installed. A magnetic flow meter was added at the Huron View site, and level sensors and cameras were installed at the Merlin site to better monitor surface runoff. In addition, runoff contribution areas at the paired North Kettle sites were corrected using aerial imagery and historic tile installation maps. This work has helped to improve the accuracy of runoff comparisons and strengthen the integrity of our overall water quality analysis. We also continue to integrate innovative tools into the program. This year, we had monthly drone monitoring at the Fairview site, which helped to expand our evaluation of soil-water relationships through the lens of crop growth and stress. And this work is helping to further link in-field observations with data generated by the SWATwater tool deployed at the site. And you're going to hear a little bit more about that tool later on with Jonathan Zeltler. Soil health monitoring remains a cornerstone of the On-Farm program, and in 2025, soil samples were collected from 7 edge-of-field sites across all benchmark locations, including 6 newly established benchmarks at the Asable Bayfield Conservation Authority Gully site and the Lower Thames Valley Conservation Authority Fairview site. In total, we have over 1,000 soil health laboratory tests that are currently being completed on those samples that were collected throughout the year. These tests include things like soil organic matter, active carbon, soil protein, soil fertility analysis, as well as aggregate stability. In addition to the laboratory testing, in-field replicated assessments were conducted at each benchmark, including soil bulk density, soil moisture, and soil temperature measurements. Together, this robust data set continues to strengthen our understanding of how best management practices influence things like soil function and resilience. The 2025 agronomic monitoring program was also successfully completed. This included replicated crop yield sampling at each benchmark location. In total, over 1,000 hand-harvested crop samples were processed for yield and crop moisture data. And a big thank you to the Soil Resource Group for all of their efforts that they do in collecting all of those samples. Best management practice implementation remained strong across the 25 farmer cooperator sites. 8 sites completed cover crop treatments and 8 completed organic amendment treatments using manure or off-farm biosolids. Reduced tillage or no-till was used at all 25 sites, reinforcing the program's focus on soil conservation and sustainability. We are starting to see some really exciting results come through from this extensive body of work. And I'm not going to go into too much detail because all of the great presenters and speakers following me are going to touch on this in more detail. But it's just really encouraging to see these early findings that are continuing to demonstrate the value of this long-term field scale research that is happening. Beyond the fieldwork, knowledge transfer remained a top priority over this past year. We hosted several events throughout the year, including 2 field days, the first being the Soil Health Day at Woodley Farms with Norm, and the From Sky to Soil, highlighting drone innovation in changing the way we farm event with Andreas from TerraLinks UAV, who highlighted the work that he is doing with his imagery. We also refined and updated the On-Farm How to Conduct On-Farm Research Guidebook, adding a practical research trial worksheet to empower producers to conduct their own trials. We had over 400 copies of this printed and developed, and these were distributed at Canada's Outdoor Farm Show, as well as local Soil and Crop Improvement Association AGMs as meetings, as well as other trade show events that we've attended over the past year. We've seen a real strong interest in this guidebook, and it's great to see so many producers interested in farmer-led research. The work completed this year reflects not only scientific rigor, but also the dedication of Ontario producers to continuous improvement. OnFarm continues to demonstrate what is possible when producers, researchers, conservation authorities, and partners work together to generate meaningful field-scale data that supports both environmental sustainability and farm profitability. Just thank you again for being a part of this important work. And I know we've got a fantastic lineup of speakers lined up for you today, and we hope you enjoy all of the information that's shared with you. Thank you.
Thanks so much, Nicole, for opening with all of that great information about the on-farm program. It's lots going on, and looking forward to hearing more about it through our researchers today. I'm going to invite Kokalan Vivekanathan up first, who is the water quality specialist at the Ontario Soil and Crop Improvement Association. And he will be joined with Rick Kutstra, who will answer a few questions. He is a poultry and grains farmer in Huron County. He's on the board of directors of the Egg Farmers of Ontario, and he is the farm manager at the Huron Demonstration Farm near Clinton. That looks great, Kokalan. We can see your presentation. Again, if you have any questions about anything that you're hearing here, we really invite you to add some questions into the question box that's provided in the links below. Go ahead, Kokalan.
Thank you, Kelly. Can you hear me?
Yes, I can. Thanks.
Excellent. Good morning, everyone. And thank you for attending today's On-Farm Research Forum. Today, you will hear some exciting talks from our on-farm soil health and water quality research. So I will kick off the water quality section by providing an overview of how runoff pathways transport agricultural nutrients, primarily focusing on phosphorus and nitrates. So today I will focus on two major runoff or drainage pathways. The surface runoff in agricultural lands occurs at the ground surface where the runoff water leaves the field through in-farm swales or depressions or through adjacent ditch networks. For subsurface drainage, we have mole drains, groundwater pumps, interceptor drains, and primarily the tile drainage. So tile drainage involves installing perforated plastic tubes underground to remove excess gravitational water and to keep the groundwater table below the ground surface. So today I will mainly focus on tile drainage as the primary subsurface runoff pathway, since more than 50% of Southern Ontario farms are currently tile drained. So surface runoff, like the surface and subsurface drainage, is critical for many farms, supporting better crop germination and establishment. However, they can also lead to the loss of sediments and topsoils from farms, which then can affect soil health and field resilience. In addition, they can also transport agriculture nutrients such as nitrogen and phosphorus along with other agrochemicals into waterways, causing pollution issues. As you could see here, that's an aerial photo of Lake Erie. So understanding how water and nutrients move within our agricultural systems will help to identify sensitive periods and best management practices to mitigate the pollutions while improving farm productivity and resilience. So today, I will be covering 4 different aspects related to agricultural runoff and nutrient movement with the focus on Canadian agriculture. First, I will talk briefly about the runoff separate partitioning between surface runoff and tile drainage. And then I will discuss about nitrate movements through agricultural drainage pathways, followed by phosphorus. And then if time permits, I will outline a few BMP is in that we as OSCIA is currently like evaluating with our partners in order to reduce nutrient losses from our agricultural lands. So in a system without subsurface drainage, much of the runoff leaves through the surface runoff pathways. However, this dynamic changes with the installation of tile drainage, as the tile drainage effectively modify valley zone hydrology and runoff volumes. So the tile drainage is expected to suppress the surface runoff. However, this role of tile drain depends on various factors. For example, soil texture. In general, chances for tile drainage is tile runoff is higher in soils with higher permeabilities or hydraulic conductivity, such as sandy soils, or soils with permanent preferential flow pathways, such as the clay textured soils. The seasonal influence. The chances for runoff is higher in wetter seasons with little crop stand over dry seasons with grown crops. Regional climate has an influence on how the runoff pathways function. For example, regions with harsh winters like Canadian prairies, they could restrict the tile flow during snowmelt runoff by because there is a almost impervious soil ice layer being created, which extends down to 3 to 4 feet depth in the winter. So that would limit the water movement from the surface into the tile drainage during the winter melt. Then antecedent moisture, wetter your field conditions, the chances for runoff are higher. And event characteristics, for example, thunderstorms with high intensity, lower duration thunderstorms usually favor the generation of surface runoff, whereas a longer duration, small intensity storm or rain events prefer the tile flow. And then finally, the configuration of tile installment. For example, flow from deeper tiles is usually higher due to their proximity to the groundwater table. Similarly, tiles with the narrow spacing can also result in higher flow. So in the next slides, I will be showing a couple of studies that explored some of these above-mentioned factors. So this figure shows cumulative tile, I hope you can see my cursor, cumulative runoff over 5-year period for 3 Ontario fields. So ESS indicates a field at Essex County. It's a flat, the field is located on a flat landscape with dominated by clay soils. Then ILT denotes Ilderton and Londesborough. These sites have loamy soils with a slopy landscape. So here the runoff is separated into 4, indicating runoff pathways as well as the seasons. For example, the greenish portion indicates the tile flow during the non-growing season, that's from October to April, and the light blue shows the tile flow during the growing season. Similarly, surface runoff non-growing season and surface runoff growing season. Sorry. So with the first glance, we can clearly find some conclusions. For example, the tile drainage was responsible for over 75% of the annual edge of field runoff in the southern Ontario landscapes. The other one is the timing of this flow. So majority of the flow occurred during the non-growing season when there are but little crop stand. So this is same for the entire Canada. So let's bring a research conducted in Manitoba on a verticolic clay soil. So here we monitored overland flow, that's your surface runoff, and tile flow over 3 consecutive years. So here again, the runoff is separated, categorized into different periods: dark blue snowmelt runoff, spring, and red for summer, and then fall. So here what we saw was completely opposite to that of what we saw in Southern Ontario. For example, the contribution of surface runoff was much greater than the tile flow, contributing to around 70 to 90% of the total runoff. And another striking observation is the lack of tile flow during this snow melt season, with substantial, almost like 99% of the snow melt runoff occurred as surface runoff. So I might have discussed this a couple of slides ago. So the reason is during these harsh winters, the soil ice layer uh, it extends to like 3 to 4 feet depth. That's where the tiles are located. So it effectively prevents water movement into the tile drainage. So, however, if you compare the runoff volumes for other periods or the warmer periods, you could see the tiles were contributing to 35 to 100% of the warmer period runoff, which is comparable to that of surface runoff. So now from runoff, let's talk a little bit about nitrate losses. When we apply nitrogen to crops, let's say urea, so it's first converted into ammonium ions, and these ammonium ions are converted to nitrate ions through the nitrification process. So nitrate ions are highly mobile in soil water and they barely interact with the soil matrix. So uh, they usually move through the percolating water through the soil matrix. So therefore, child nitrate losses have been a concern for early studies. So in general, the elevated child nitrate losses can be seen in continuous cropping systems. For example, some studies from Southern Ontario that published like 50 years ago, they found in elevated child nitrate losses from continuous corn systems. Fertilization strategy could be another factor that could affect nitrate losses. Or some organic amendments have been applied at higher rates, for example, liquid swine manure or poultry manure can also exacerbate tile nitrate losses. Agrochemicals such as the application of glyphosate can also increase tile nitrate losses due to increased mineralization. On the other hand, the introduction of non-leguminous cover crops, no tillage or straw mulching, those practices could reduce your runoff nitrate losses. So let's quickly look at some of the data. So here this box plot shows the nitrate concentrations from surface runoff SR and tile drainage for two different Ontario sites. The Merlin sites are part of the on-farm program. The data has been collected since 2017, where the researchers compared the surface runoff and surface runoff and tile nitrogen. And also Strawberry Creek, these sites is located just 20 minutes from the city of Guelph, so it's very close. So this is a recent data collection. So when you compare these concentrations, you could clearly see the tile nitrate concentrations were consistently elevated for both Merlin sites and most of the Strawberry Creek sites. So when you pair these higher nitrate concentrations with higher tile runoff volumes, which is intrinsic to Southern Ontario, you could expect more tile nitrate losses from these soils. Let's quickly talk about phosphorus now. So phosphorus losses through the tile drains did not receive much attention until the late 1990s. So in general, we consider phosphate ions as like they can be fixed into the soil. So, and then historically, the surface runoff is believed to be the primary transport pathway for phosphorus. However, when researchers began looking into the child phosphorus losses, they noticed increased or like elevated child phosphorus losses at for some cases. So what changed here? So let me explain this with a very simple diagram. So here you have precipitation coming down. So depending on the soil's infiltration capacity, it could generate surface runoff on the surface. And then we have the two different phosphorus species marked. DP indicates dissolved phosphorus, the dissolved fraction of phosphorus, and particulate phosphorus that's mainly associated with sediments. So on the first pathway, the water and phosphorus, they moved through soil matrix. This is relatively a slow procedure, allows water and nutrients to interact with soil, allowing sorption, desorption, or filtering reactions based on soil's phosphorus saturation capacities. However, there is another path that's been driven by macropores. So what are these macropores? So by definition, any soil pore or channel with a diameter greater than 2 millimeters is considered a macropore. So the macropores include earthworm channels, animal burrows, root cavities, and desiccation cracks. So what do is they short circuit the surface water directly to the tile drains with a less interaction with the soil matrix, and thus disproportionately contribute to elevated tile phosphorus losses. So again, let's look at the phosphorus losses from the previously described Ontario sites, Essex, Landesborough, and Ilderton. On the left, we have the cumulative flow that I described earlier. In the middle, you have the graph for showing SRP, soluble reactive phosphorus losses. So that's the fraction of phosphorus that's readily available to algae. And then on the right, you have a total phosphorus, which includes both soluble phosphorus and particulate phosphorus. So at Ilderton and Landesborough, more than 60% of the SRP and total phosphorus losses can be attributed to the tile drainage. Again, most of the these losses occur during the growing season. However, Essex, there's interesting stuff was seen. Despite smaller summer tile flows, you could see substantial amount of phosphorus being moved in the summer during through the tile drainage. So as I discussed earlier, the Essex soils are clays, and they do have permanent like macropore pathways. So that so these observations indicates how the subsurface is continuously connected to the surface throughout the entire year. So another observation about the role of surface runoff here, especially at Essex and Landesborough, the surface runoff volumes during the non-growing seasons were not that much compared to the tile drainage. However, look at the phosphorus. For example, in Landesborough, the SRP loads, and at Essex, the TP loads, they are significantly higher, indicating even though with the less volume, the surface runoff is still a critical pathway for phosphorus losses. So far, I've discussed tile floor activation and partitioning and tile nitrogen and phosphorus losses. So what we can do to reduce these losses while improving the productivity. So optimizing productivity with minimal environmental impact is encouraged through the 4R management. The 4R stands for right source, right rate, right time, and right place. I'm not going to spend much time on this, as Emily will discuss 4R nutrient management after this break, elaborate in detail. Before I wrap up, I quickly go through some of our on-farm sites and the BMPs that we are evaluating with our partners in order to reduce nutrient losses from agricultural farms. So first is the Gully Creek site. So here we are along with Osable Bay Field Conservation Authority. We are evaluating the impact of surface cover on runoff generation and nutrient losses. Having a continuous soil cover, especially in the non-growing season, can reduce surface runoff and minimize sediment and nutrient losses. At the Huron View demo farm, the ABCA also evaluates the BMPs such as tile configuration, cover cropping, and nutrient management for the effects on runoff and water quality. At the Upper Medway site, Agriculture and Agri-Food Canada assesses the controlled drainage. Here, we control the flow from the free-flowing tile drainage by installing a gate-like a structure close to the tile outlet. So controlled drainage is found to be increasing your crop yields while reducing nutrient losses from the runoff. At the North Kettle site, the Upper Thames River Conservation Authority evaluates the impact of cover cropping on water quality using a paired site approach. At Merlin, again a paired site, the Lower Thames Valley Conservation Authority evaluates tillage, fertilization, and cover cropping practices. They also monitor the Fairview site where we explore the impact of manure application on runoff and other soil and crop parameters. So next, we will hear more about some of these sites and the exciting research underway from our partners. Thank you very much.
Thank you so much, Kokalan. It was really informative. And I'm asking folks to put some questions into the question box if you have any questions for Kokalan. I have one that just was wondering about. You talked about the different depths for drain tillage, and I'm wondering if there's an optimum depth in terms of nutrient runoff. Like when people are putting in tiles, should they, when they're thinking about that?
It really, I guess it really depends on the to reduce nutrient runoff. No, but I guess like the tile depth is mainly decided by the contractor depending on your location, site, and the
Right.
proximity of the groundwater table, because the primary objective is to like keep your groundwater table low. So for my objectives in Ontario or Southern Ontario, I would say the depth of tile drainage is average 3 feet. In Winnipeg, they go a little bit deeper because the groundwater table is deeper there. Like it's not a shallow groundwater table, it's a semi-arid area.
Right.
So yeah, like having a tile drain closer to your groundwater table potentially increase like your nitrate losses, because groundwater is mostly like groundwater is nitrogen rich resource, so probably gonna like result in more nutrient losses.
More movement. Okay. Thanks, Kokalan. Gord is asking, can you comment? Hold on a second. Let me just move this. Can you comment on nutrient losses amounts in context of farm economics? Example, pounds per acre versus environmental impact.
Well, so for the nitrogen, I guess like the losses from the tile drainage could be significant, like 20. I've seen like values like ranging 20 kilograms or something like that, 10 to 20 kilogram per hectare. Sorry, like then it's like 20 pounds or something. But for phosphorus, these values are fairly smaller. Like some farms, it's just like 1 pound per hectare, but some farms like 1 to 2. So it's very minimal for phosphorus when compared to nitrate losses. However, from an environmental standpoint, the phosphorus is more critical even with smaller concentrations, because most of our freshwater body in most of our freshwater bodies, the nitrogen fixing cyanobacteria is the main culprit for the eutrophication. For them, nitrogen doesn't matter. So they can fix by the nitrogen by themselves. However, phosphorus, even in small quantities, that could trigger an algal bloom. So that's why more concern when it comes to phosphorus, even though like the losses from farms is not that very much when we quantify them.
Thanks. That's great, Kokalan. We appreciate that answer. We're going to keep moving forward here. As part of your segment, we're going to ask Rick Kutstra to join us. And I believe Mary's going to share a few slides. And then it's great. Renee Bowler has been able to join us, ran into a few traffic problems. So after Rick's segment, we'll hear from Renee and then move back into our program. Rick, are you there?
Hello, good morning.
Good morning. Great. Mary's sharing the screen. I have a few questions for you. So, Rick is our farm cooperator. As I mentioned, he's the manager of the Huron View Farm and has a lot of experience with runoff and working with the on-farm program. So, I wanted to ask you a few questions. Do you want to just first of all describe your current farming operations? What do you do at your farm?
Okay, so we're poultry cash crop. So we produce chicken and eggs, and we take that resource and apply it to the land as fertilizer. And over the last 30 years, have moved into no-till and strip-till, and within the last, I'd say 15, have really ramped up cover cropping. Now it's sort of hit and miss, but we're seeing huge benefits. Uh, so
Oh,
that's sort of the whole program. Yeah.
that's great. I'm going to ask you a little bit about those benefits in a second. Knowing that water movement is a key factor in moving nutrients on farm, where and how do you break up the nutrient water pathways?
Okay, so we start there with firstly, Canada has more water than all the other countries combined. So we have lots of water.
Right.
The key to this whole thing, finding solutions, is that it isn't the water, it's more the disposal of after we've used it. So that applies to agriculture as well as industry or town village. Um, what do we do at the farm? The only thing we can do is slow that water down. So we're very careful with our our tiling process. You don't necessarily need to be every 15 feet. You can be 40. It's depending on your soil type or your farming practices. Um, I'm finding that the better the cover crop, the stricter the rotation, the less runoff I have, or I'm slowing that water down. So can I go to the creek or the river and take a test of my water versus another farmer and find I'm less? I think so, but I don't have all those proofs in line. But uh, the worse your soil, the quicker our nutrients leave us. It's like a flush. So it rains, the faster it leaves. So when Copeland is describing all those things in his presentation, it's very true. Like we're seeing huge nutrient losses because our soils are depleting. Uh,
Do you find your practices of no-till and strip-till helping with that?
it's a gradual process. It takes time. It isn't instant.
Right.
You're
Okay.
going to go, it's going to take you 20 years or 10, or depending on your soil type, depending on your rotation, uh, and of course, fertilizer usage. That's why manure is so beneficial because it's natural and it's non-chemical. So the soil
Yeah.
likes it, crops like it, it's plant available.
Yeah. Fantastic. Does anybody else have questions that you want to pop into the question box for Rick? You had mentioned the on-farm program and working with Coquilama. Can you tell us a little bit about that collaboration, and are you finding it's beneficial to your farm practices as well, what you're learning through this program?
Okay, so are we talking about me or Here in View now? Which would you like?
I don't know, which is the better answer. It's up to
Well,
you. Huron View would be great, actually.
okay, let's go to Here in View. So this is a picture on your screen of Here in View. That's a drone seeded cover crop, 50 pounds per acre with the drone. We had a great establishment. The orange you see there are just leaves, and that's what we're working with. again, what are we doing over there? Right now, we're going to start in on or we've been working at a sub irrigation project that is um, starting to. We're getting closer to install. We're working diligently at this. Is that necessarily for irrigation for the crop? Well, it is. That's our main focus. But a second and also very important focus is that we're now able to take water that may or may not have nutrients in it and reroute it back to the crop rather than to the environment. And I think that's very important. We can use that line with regard to your question on pathways. We can use that line of thought just about everywhere. So you go to a town or a village or a city and say, I'll take that street water and I'll farm with it. I may have to filter it, but we can farm with it. We can also take farm runoff that's full of nutrients and say, no, it's not ready for the river. We'll bring it back and reroute it. Now, these are expensive ideas, but it doesn't all have to be 100 acres at a time, too. You can do 5 or 6 acres of that runoff. But every time you reduce the nutrient level in water, well, we can go to Copeland's demonstration here of all those things and then reduce them dramatically. And that's kind of what we're looking for at Here in View.
Yeah, that's great. Somebody's asking, how does poultry manure compare to other manure, in your opinion?
Like, are you asking for who has the best manure, or?
Well, that's the question. So I don't know. Danny, do you have anything to add to that question? Have you tested different manures, different inputs
Manure.
at you?
So our poultry manure will have the highest nitrogen.
Right.
Best manure maybe be sheep and horse. There's some really great benefits to cattle. Broiler and layer manure differentiate themselves based on bedding. So
Right.
layer is pure, whereas broiler has the mix. What's preferable for crop growing? Well, poultry manure is like an injection, like it's a straight shot. Whereas some of the other manures break down, there's a lot of bedding mixed into them. So the importance of using a cover crop and spreading manure is what paramount, because we're dumping a straight manure onto the soil. So it's really nice to have cover crops in there or a residue to keep that in place.
Right. That makes sense. Danny says that's what I was hoping to hear. Hearings for your findings, and thank you very much.
Okay.
Well, that's great, Rick. I'm going to actually wrap us up here. We have to keep going with our forum and additional speakers. Mary, do you want to stop sharing the screen maybe for a minute? And I am going to introduce Renee Bowler. Hey, Rick. Renee is the Assistant Deputy Minister of the Food Safety Environment Division at OMAFA. With over 25 years of Ontario public service, she has held technical, policy, advisory, operational, and management roles across the three ministries, contributing to legislation, policy, and program development while leading teams to deliver impactful results for Ontarians. I'm going to let you all continue to read Renee's bio in the guidebook that I offered you this morning. Renee, are you there? And we can.
Yep, I'm here. Can you hear me okay?
I can, and I can see you now.
Excellent.
Welcome. It's great to have you here.
Thank you. And apologies again for being a little bit late today. I did manage to catch most of the first session though, and I can see that you guys are already off to a great start, which is awesome. And thanks. It's a real honor to have a chance just to say a few words here today. I'll keep it brief, knowing that your program is already in session, and my traffic delays made me a little bit late. But in any event, it's already clear to me that the folks that are attending this great session here today already know the importance of ensuring that the agriculture sector here in Ontario can continue to be resilient, self-reliant, and competitive. It's a challenging and rapidly changing world out there, and I think all of us here understand the importance of being able to continue to have a strong and thriving ag and food sector for the benefit of not only those in our province, but for the strength of our economy and really for the rest of Canada. And further, I think everybody here understands that soil and water are literally the foundations of that resilience. We have to figure out the best ways to manage those resources and look after them, because they really determine the long-term viability of farmland in every corner of this province. And we have quite a varied province in that regard. And so that's why the research that we do in this space is so important for long-term sustainability. On-farm is really critical to our ability to improve our understanding and improve our practices. And really, I think we can all appreciate that it's become a pretty vital research hub. So it's really helping us work together across the sector and in real life situations, partnering between, farmers and researchers to improve our understanding of how best management practices can really improve soil health and water quality and productivity of our farms. So, that's really what we're after. And when I look at the agenda for today and the sessions that are on offer, it's really great to see the focus on nutrient management, active stewardship of soil and water. And it's great to know that these priorities that can help us be sustainable over the long term are receiving some really important attention and excellent leading edge research. And it's always, of course, good to see that that's happening right here in Ontario. We need to have this research happening here so that we know it's applicable to farms here in Ontario. I think events like today's forum especially are essential to achieving our collective goals, because we're bringing the people together that matter and that have a stake in this space to share insights. And this is our best bet for influencing on the ground adoption of practices that can help us strengthen our farmland and contribute to productivity and environmental stewardship. I do want to recognize as well today the great leadership of the OSCIA in delivering this program. And I do want to express real deep gratitude to the farmers and researchers that make this work possible. All this effort to improve our ability to manage nutrients responsibly, explore use of cover crops, reduce tillage, improve drainage, all the efforts to help build soil structure. We know that these types of activities are what is going to keep Ontario the agri-food powerhouse that it already is. So we're going to strengthen our productivity and also have higher crop yields. And so those are gains for everyone. It's great that we're generating real world data from working farms across Ontario through this program. And we do know that since this program launched in 2019, it's made real significant contributions to our understandings of soil and water health in Ontario. For farmers, I think this research is really important as well, because what we're aiming for here is to develop this research that reduces the risk associated with changing practices, right? It can provide clear evidence of what works, where it works, and under what conditions. And the idea here is that we can provide information needed to make science-based decisions that protect the long-term resilience and productivity of farmland. The program has really celebrated a ton of success, and I just want to highlight a few recent ones. including the new research partnership between OSCIA and the University of Waterloo, the successful Did You Know social media campaign that promoted ONFARM and also helped to educate the public on the importance of best management practices and the work that's underway to make sure that agriculture is undertaken in sustainable ways and incorporating sustainable practices while increasing productivity. These are real achievements, and I know today we're going to hear a lot more about research that's underway and with a chance to chat about it with the researchers and the farmers that have participated in the studies. So I do want to hand the mic back so that the program can continue, but I do want to thank everybody here today that has attended. Thank you for your commitment to this important work. Thanks for your curiosity and your collective leadership in this space. And I hope you feel good knowing that the work that you are doing is really helping to build a more resilient, productive, and sustainable future for Ontario agriculture. So thanks again for letting me say a few words today. Really happy that OMAFA can support this important work, and have an informative and inspiring day. Thanks for having me.
Thank you so much, Assistant Deputy Minister. We really appreciate your words, and we appreciate OMAFA's partnership, recognizing that this work is important to informing agricultural policy and practices across the province. It's good to know we're not just talking amongst ourselves, so we really appreciate you being here. Thanks
Happy
again.
to be here. Thanks.
Okay, we're going to continue on with our program here, and we're going to move into the research and management strategies to limit runoff nutrient losses. And we have 3 speakers from conservation authorities here who really put these ideas into practice and work with our farm cooperators. I'm going to introduce sort of all 3 of them, and then they can just take this session and run with it. And again, please add your comments into the Q&A section under the 3 dots where it says more. You'll see the Q&A there. We're going to welcome Mary Velez from the Ausable Bayfield Conservation Authority. She will speak to us first. Then we will have Beth Rona from the Upper Thames River Conservation Authority, and then Brittany Littlefield from the Lower Thames Conservation Authority. They will each have a short presentation here, and then we can ask them a few questions afterwards. Mary, do you want to share your screen?
Yes, everybody can hear me okay?
We can.
Okay, I'm going to move to the slide layout.
Perfect.
Okay, thank you.
Thanks.
Thanks very much for the introduction. And I just wanted to kind of frame where we've been already this morning, which was Coquelan giving an overview of the nutrient pathways. And then Rick talked a little bit from the perspective of the practical perspective of how we're trying to break up some of those pathways. And then the conservation authorities are going to speak to how we're evaluating the effectiveness of the practices that are happening with real world data. We are cognizant that we are hoping to grow bountiful crops, but also manage our soil and water resources. So I'm going to speak a little bit about using small watersheds within fields to collect water data. And I've done this in Huron County, Gully Creek edge of field sites. And this is just a schematic of the concept. So this is all one field. However, what we're trying to do in this one field, and have been doing this since 2017, is apply a best management practice in this particular area of the field. This particular area is in some way separated from the other part of the field in that it has a berm holding back some of the water, and we can then collect that water. Same with this other area within the field. It also has a berm at the downstream end, and we then can collect the water just upstream of that berm. As far as the size of these fields go, this is 8.8 acres, the best management practice, and the business as usual practices are on 7.17. In this particular example, this picture was taken in October 2024. The farmer had applied 60 pounds, of cover crop seeds, 98% oats and 2% peas. There's 6,000 gallons of dairy manure in most of the field. In the front of the field, though, there was 4,000 gallons of hog manure. So I'll talk a little bit about the results of that study in a moment, but first I'll go over a little bit of the crop management and data collection. So the typical crop rotation at this site is corn, soybeans, winter wheat, and there's typically an oats and peas cover crop following the winter wheat harvest. The comparison that I'll be speaking to is the cover crop versus the harvested cover crop in 2020. And in 2024, there was also well, you just saw the picture that there was a cover crop in the best management practice area and no cover crop in the business as usual side. And then there's also this last year, we flew rye and or oats in part of the field in the standing corn. So the data that we collect the precipitation data, we monitor surface water. Copeland talked about the different ways that water moves in the field. In this particular field, we're only studying the surface water runoff that's collecting behind the berms. We do collect, we have level loggers in the field that help us calculate the storage, and the level and storage relationships help us calculate the flow and generate runoff coefficients. But really what I have found over the years is that the simple presence and absence of flow under various crop conditions can be quite informative. We also take water quality samples for total suspended solids, total phosphorus, dissolved reactive phosphorus, nitrate, unionized ammonia, and total Kagel nitrogen. So this is the same field, just with a different perspective so that you can kind of see the layout. So this area here is the best management practice field, and this area here is the business as usual field. And you can see at the base of the water and sediment control basin, we have Higginbottoms, and you can even see the little level logger there. This picture on your left is the picture of the harvested cover crop in the business as usual area and the unharvested cover crop in the BMP area. In the far right, you'll see there's the picture of the rye coming up in the standing corn this winter. So first I'll speak a little bit about the 2020-2021 season, the harvested area versus the unharvested oats and peas. There were 13 precipitation events that winter and 3 snowmelt events. We had runoff generated less times in the unharvested area, sorry. So 1 out of 13, and no runoff was generated during the snowmelt. Whereas with the harvested area, we had runoff generated 31% of the time. And all the times that the snowmelt happened, there was runoff. So the loss of phosphorus and total suspended sediments were quite a bit higher, twice as high in the harvested area. If I refer to this particular winter, this 24-25 season, there weren't as many melt events. So the one event that we did catch was at the end of December, and you can see here in the relative comparison between the best management practice watershed versus the business as usual watershed, we had a considerably higher concentration of total suspended sediments leaving the bare field compared to the best management practice field, and same was true for the total phosphorus. The dissolved concentrations for phosphorus were similar. The nitrate was higher in the business as usual site. I mentioned the importance of just the simple presence and absence of flow. And this is really important, and Coquelin and Rick both alluded to this, is that not only is there the nutrients we're wondering about or worrying about that we put on the field, but it's actually just that ability of that field to hold the water, because this is just this is a 100-acre field in a 15-kilometer square watershed. But if it's generating water, other fields are generating water at the same time. And it's actually in some of the work we did earlier in Gully Creek, it's actually all the water hitting the downstream at the same time that is eroding the downstream channel that is also responsible for some of the losses of phosphorus from the overall watershed to downstream water bodies such as the lake. So 59%, for instance, in Gully Creek is coming from that stream channel erosion. So anytime we can hold the water, the better off we're going to be. This is just an example of the kind of information that we can get from the longer term studies. So what we have here is by year, the number of events we had, the business as usual response events, that's that one watershed versus the BMP events. And you can see over time, at the beginning, they were more the same, and that towards the end now, the business or the best management practice one is maybe slightly less responsive than the business as usual. This isn't the kind of work you can do in one season. It takes quite a bit of time to, first of all, develop the methods, understand what you're beginning to find, and then have a crop rotation or two to go through to see how things are responding. Now I'm going to switch to the other site, just to another example of using the small basins to look at best practices. And this time it's for tile drainage. So this is the Huron View site. Here's the Bayfield and River to the north of the site. The front field that you see is the contour drainage. In this particular example, this contour drainage has a gate on the end of every one of those laterals. At the back here, there's this typical symptomatic pattern tiling every 30 feet. And then we did leave a no tile section. I'm actually not going to talk that much about the main study here today. I'm going to talk about the fields to the back of to the south of the Huron View site, where we also did a demonstration of contour versus pattern style drainage. Those contours are without gates. So I just have some results over the last 5 years that we've been collecting the data. So when we look, I didn't correct these for the area. The area are very similar. The pattern one is just when I do correct them, even for the area, so it would give you, instead of a meters cubed, if I give you a millimeters, the results are similar in that we're getting more water leaving the pattern drain field compared to the contour drain field. And why some of this is because of the slope of which this contour drainage is put in. It's put in at a very gentle grade, 0.1% grade, so less water does leave the site in this at our site here that we're finding at Huron View. So that is one of those ways that we can manage water and therefore break up some of the nutrient pathways. Okay, so I just want to thank the participating producers, because it can get kind of busy when you're already trying to do planting crops and things, for someone to say, okay, can you just leave this one little part without the cover crop? So, and they're wondering, well, aren't you trying to study the cover crop? So it's been I'm very grateful to the participating producers, not only in my area, but along all of the on-farm sites, because this can be a bit more work. So thank you.
Thank you, Mary. That was really great. Super informative. There are a couple questions in here. I think we're going to wait till the end of all 3 presentations, if that's okay, to get through our questions. And so then we're going to invite Beth up to provide her presentation as well. Go ahead, Beth.
Okay.
We can see your screen.
Thank you.
Thanks.
Sorry, I had to turn my speaker on. Good morning, everyone. My name is Beth Rona. I'm the Agricultural Stewardship Technician with the Upper Thames River Conservation Authority. And today I'm going to show you some results from the Upper Thames North Kettle Edge of Field site, which is just south of London and joined ONFARM in 2020. So here we're comparing cover crop and no cover crop treatments for impacts on water quality and quantity leaving the field. where the north field is cover cropped and the smaller south field is no cover crop. The fields are separated by a double basin loss gob and are both randomly tiled with surface inlets. And the crop rotation is alternating sweet corn and soybeans with cereal rye, winter wheat, or oats cover crop in the north field. And for management, the soybeans are no-tilled into sweet corn residue, and following soybean harvest, a cover crop is drilled or worked in and left over winter. And for sweet corn, the cover crop is sprayed in the spring, and then the field is cultivated twice before planting. And after sweet corn harvest, a cover crop is drilled or worked in and left over winter, and the cover crop is again sprayed off in the spring before no-tilling soybeans. And management is the same in both plots with the exception of manure application and cover crop only on the north field. And for this presentation, I'm going to be sharing some observations in seasonal trends in nutrient concentrations, particularly looking at spring concentrations following fertilizer and manure applications ahead of planting. So here we're looking at seasonal trends in nitrate concentration specifically. So these graphs represent 6 years of data collection where the north field is on the left and the south field is on the right. We do event-based water quality sampling in the tile. So, excuse me, multiple samples collected over an event and many events throughout the year in addition to periodic base flow sampling. So in this plot, the green hatched bars are periods of crops and the blue is cover crops, which as a reminder is only on the north field. And triangles at the top of the plot are showing timing of tillage in teal, fertilizer in pink, and manure in yellow. Again, the manure is only on the north field. So a couple things to note. In 2022, we have a gap in the monitoring record, so we didn't collect water quality samples in that year. And 2023 was a very wet year, so the farmer had applied manure to the north field and did vertical tillage, but because it was so wet, instead, it only applied an oat cover crop to the field and did not apply chemical fertilizer. And for the 2023 growing season, there was no living crop on that subfield. So when we're looking at seasonal trends, what we've observed in these spikes in nitrate concentrations following manure or chemical fertilizer applications and tillage in 2021, 2023, and 2024. And it's important to look at the spikes relative to measured concentrations before and after to get a sense of the magnitude of that first flush period. And what I really want to highlight here is the time frame between these manure and fertilizer applications and nitrogen concentration spikes that we're observing in those runoff events. So in 2021 and 2023, those spikes were within 1 month of those applications. And in 2024, that spiked within 1 week of that application. So by contrast, in 2025, it was a very dry year. So despite applying fertilizer ahead of soybeans, we really didn't see the precipitation driving runoff events as we did in other years. So next, we're going to zoom in and look more closely at this July 2024 period. So in spring of 2024, they broadcast 2,000 gallons per acre of liquid poultry manure with a spray hose on the north field and incorporated it with vertical tillage the following day. Then on July 1st, they cultivated ahead of 200 pounds of split K-Mag and Mez applied with the sweet corn planting. And now I want to highlight that they are incorporating the manure and fertilizer and timing those applications for when there's less likelihood of runoff and ahead of planting for when the crop needs it. And in the fall, they're putting on a cover crop after harvest to help tie up those nutrients and keep the soil in place as well. So the top plot is showing daily precipitation totals with the orange bars, and the smaller red bars are hourly totals, so we can better see the intensity and duration of those precipitation events. And in the bottom plot, we're specifically looking at tile runoff from the north field, where the blue line is water level measured in the tile monitoring port. So as a reminder, we had manure applied and incorporated in mid-June and fertilizer applied and incorporated at the beginning of July. So following this, we had 2 significant periods of rain starting on July 10th, which was longer duration, totaling almost 60 millimeters of rain, resulting in 11 millimeters of runoff from the north field. And just a few days later, starting on the 15th, we had 2 periods of high intensity rain totaling almost 90 millimeters, resulting in 26 millimeters of runoff from the north field. So visually, just looking at the field during this time, we had significant surface ponding at the Hickam bottoms, which were very turbid water and evidence of foam on the north field, which did receive that manure application. And we chose these specific events to show within a period of less than a month just how different the response can be from event to event and how different drivers can play into those nutrient losses. So here we're looking at water chemistry for the same period in July 2024. So in our case, we're capturing water from surface runoff into the Hickenbottoms as well as subsurface from random tiling in the field. And on the graphs, the blue line is again water level measured in the tile monitoring port, and dots are sampled nutrient concentrations in milligram per liter. So we're looking at total suspended sediment, total phosphorus, nitrate, and soluble reactive phosphorus. And when we look at nutrient concentrations relative to the size of the event, what we expect is when we have bigger runoff events, we will see higher sediment transport, which is true for these events for TSS. Similarly, looking at total phosphorus, which includes both soluble and particulate forms of phosphorus, when we have larger events with more sediment transport, we can expect more particulate phosphorus to move as well. So here, the main driver for these spikes in concentrations is precipitation and the size of the runoff event. Conversely, we're not seeing the same relationship with nitrate and SRP concentrations here, where in these early summer event examples, we have higher concentrations, not matching up with the larger flow events. And instead, we have relatively smaller first event, which has this big first flush of both nitrate and SRP following those manure and fertilizer applications, which is not seen in the following larger events. And to help understand the differences between total phosphorus and SRP contributions or concentrations from the last slide, we need to look at the breakdown of particulate phosphorus and SRP loads in these events. So in the first smaller event, there is less sediment transport as we saw in the TSS concentrations, and we have greater SRP contribution than particulate coinciding with that first flush following nutrient applications. And by contrast, in the second larger runoff event, where we have larger particulate losses driven by the size and intensity of the precipitation event, particulate dominates the total phosphorus output in that event. So in this case, the likely driver of these losses is the proximity to those land management practices rather than the size of the runoff event. So this is in a situation where they did incorporate the manure and fertilizer, but we still see these losses when these applications are so quickly followed by these large precipitation events. And as a reminder, by contrast, we did not see the same losses in 2025 because it stayed so dry following planting. So where do we go from here? So this is ongoing research, and the objective of this on-farm project is over multiple years to assess long-term trends in nutrient losses to be able to make recommendations to reduce those losses. And manure and chemical fertilizer are both sources of nitrogen, and we often see higher SRP losses following fertilizer applications. And we often talk about nutrient losses in the non-growing season, but we've seen that the spring is also a sensitive time if those management practices coincide with runoff events. And ultimately, it's not realistic to bring nutrient runoff to zero. And even when you're doing all the right things, we can't control the weather, but we can limit those losses by following for our stewardship practices, like using banded applications or incorporating after broadcast, as well as splitting applications to times when crops can more efficiently uptake nutrients and using a rate in line with what the crop actually requires. And that's all I've got for you.
Thanks, Beth. That's great. Again, we have a whole bunch of questions popping into the comments, which is fantastic. And we'll just invite Brittany to share her screen, and we will get all of those questions answered at the end of this.
Can you see my screen?
Yes, looks great.
Perfect. Okay, so my name is Brittany Littlefield. I'm the Soil and Water Quality Technician from the Lower Thames. And today I wanted to talk about different management practices, either tillage and different application methods, and how that affects non-growing season water quality parameters. So the site we're going to look at is Merlin A. The site was established in 2016, but became part of ONFARM in 2019. It is on Brookston clay soil, is systematically tile drained, usually has a corn, triple soybean to wheat rotation. It used to practice conventional tillage with no cover crop, but since May of 2023, it has been practicing no-till. The plot is separated into multiple subplots. We typically collect the data from plot 2 and 3 circled up here. At each site, there are samplers and different AV sensors. There's also a surface flume with samplers and depth measurements in order to get the water quantity and quality coming off the field. So this presentation is going to look at different tillage and application methods. In 2019 and 2020 non-growing season, the year was tillage conducted 2 passes with a cultivator after 125 pounds per acre of MAP was applied within 48 hours. And then we're going to compare that to, there's no-till surface broadcast, happened in 2023 to 2024 and 2024 to 2025 non-growing season. It was the same fertilizer rate applied, but it was broadcasted in a no-till system. So we're basically just going to look at the different water quality parameters and see how they reacted under the different management practices. So the first parameter we're going to look at is nitrate. So nitrate seemed to be higher in the no-till surface broadcast treatment. It's likely known or likely due to increased water yields through macropores or preferential flow that tends to be associated with no-till. There was some variability between seasons temporally because all this data is collected over multiple years. There's different event sizes, precipitation timing, so there's a lot of variability there. And we can see some of that in this graph over here. A paper by Dr. Mary McRae et al. Basically found that nitrate levels were elevated after a prolonged drought. So in this case, in 2020, 2024, 2025, there was the no-till system. There was an event in mid-August and then a drought all the way to mid-December. And the concentrations following that drought were significantly higher. And that also lines up with the higher values here when you compare the flow wheat mean concentration. So it just was likely attributed to longer period of nitrification in that system that eventually got flushed during that December event, leading to the higher concentrations. So it just shows that because nitrate's very mobile, it can vary depending on the season. Also, the next parameter is total phosphorus. Generally, the range for total phosphorus flow wheat mean concentrations were quite wide, as you can see in these graphs, but they were quite comparable. No-till surface broadcasts seem to be a bit lower than tillage and incorporation for loads, and it was hard for surface runoff to get a good comparison because it's such a low amount of samples during a year of events, because mainly runoff happens through the tile. But you can see a general comparison. For phosphorus, it tends to focus primarily on the fractionalization of phosphorus. So we usually look at the amount of SRP, or soluble reactive phosphorus, and particulate phosphorus to see where the big differences lies in the management practices. So looking at the tile runoff here, you have a higher percentage of particulate phosphorus lost during events. But when you look at no-till surface broadcast, there's a higher percentage of SRP lost. This pattern kind of mimics in the surface runoff results as well. The higher SRP levels in no-till surface broadcasts are likely attributed to the surface application of the fertilizers in the fall. Because when precipitation events happen, the water is more likely to interact with the fertilizer on the surface. And with no-till having more macropores, it has a more direct route for those nutrients to go into the tile. Similarly, with the high concentrations found in surface runoff, that high concentration water sitting on the surface, it has an opportunity to go out into the ditch from the surface runoff. Tillage does two things in this aspect. It incorporates the fertilizer into the soil. So when water has less, there are less macropores from tillage occurring, it allows the water to go through the matrix flow instead of going down through the macropores. It allows the phosphorus more opportunity to absorb and bind to soil particles, and decreasing the opportunity for loss in the tile. Explaining some of these lower values for tillage here, because the fertilizer is below the surface, the incoming precipitation, there's less opportunity for it to mix with the fertilizer and go be lost from surface runoff. Similarly, with Beth's presentation, we found high particulate phosphorus. It tends to be higher with tillage. In this point, tillage and surface disruption from tillage tends to cause the macropores to go away, so it goes through matrix flow. There's more opportunity for the water to come in contact with soil particles and to be lost to the tile. Similarly, because the topsoil is disturbed, it's more likely to be lost from surface runoff. We found a strong correlation between particulate phosphorus and total suspended solids. It makes sense because total suspended solids are just the undissolvable particles found in water, and as particulate phosphorus is typically bound to soil, it would make sense that they would be correlated. And in these both cases, particulate phosphorus was significantly different in these treatments, as in no-till did a better job at reducing erosion of these soil particles in these systems. So this is a summary chart. It shows the different application methods, tillage versus incorporation, and no-till and surface broadcasts. It shows the trade-offs of the different parameters. While no-till and surface broadcasts helps increase infiltration and reduce erosion loss, that's shown in the lower particulate phosphorus and total suspended solids, it does have more direct pathways to lose some of the more mobile nutrients when compared to tillage and incorporation. Because the fertilizer is under the soil, it reduces the chance for water contact and boosts your absorption opportunities. So in the end, because erosion is so high in the tillage and fertilizer, their total phosphorus ends up being equal for loss. So what are kind of the things we can do to manage this? So this field in general is on a Brooks and clay soil. So the soil particles are very fine, very high erosion risk. So no-till in this case is really good. But it needs to be combined with something else in order to manage the management trade-offs between these practices. Things like subsurface applications, split reduced application rates, plant or applying fertilizer before planting and avoiding big precipitation events can really help. Applying things like cover crops to help keep nutrients in the soil and reduce erosion risk can help, but you need a combined approach to help mitigate some of these management trade-offs and to help keep the nutrients in the field for the next growing season. And yeah, that's all I have.
Thanks so much, Brittany. Really informative. I really appreciate your slides at the end that sort of show us the overview of everything and how it works and some of the trade-offs that you have to go through. We have a few questions in the question box for all three of you. And I think I will start at the top here. Hold on. And I think this was a question for Mary. And the question was, what rate did you broadcast rye into the standing corn, and what stage was the corn at when you applied it?
Hey, thanks. I wrote down the answer during part of those other presentations, but and I had to double check it because there's a lot of numbers. I can't remember them all, but we did broadcast 40 pounds of rye in the best management practice area and 50 pounds of oats in the business as usual area. And we seeded it with a drone on the standing corn on September 18th. And I'm not an agronomist, but I would say that would be mature corn. It was not completely dried down. It did take time this year to dry down the corn. And I think it's important to note that that particular planting was a good catch, resulted in a good catch because we had some timely rains. And then we did try to do that at Huronview a little, well, later in the season, and we didn't get the timely rain. So we'll see what happens in the spring. So that's what I've got there. I hope that answers Brad's question.
That's great. Appreciate it. There's another question. In terms of water and nutrient holding capacity of soil, do you see a decrease of this ability with lower carbon reserves in the soil matrix? Would returning carbon to the soil matrix raise its CEC and this curve the loss of water and nutrients, keeping it available within the root zone, keeping it from going downstream as runoff?
I can take a crack at it and then people can
Great.
add.
Sure.
I think that there's been lots of work showing with increasing organic matter, the ability of the soil to hold water. I think that's one of our most effective approaches to managing water and nutrient loss in fields is to improve the organic matter. Some of what you're maybe asking is a bit more specific, and I think that Don King would be better to address the specific indicators of carbon, and I think he's looking at some of that. But I think the main premise would be that if we improve the soil organic matter with proper cropping, with nutrient amendments, because the plants really are what's providing some of that biomass for the bacteria and everything. So I think that improving organic matter will improve the water quality. Oh, so you're talking about carbon, not organic matter, straight carbon such as biochar. I know we did do a bit of an experiment. This would go back more than 12 years now on biochar, and some of the guys, I could follow back up. I don't remember explicitly that. We didn't do the water sampling. I think we just looked at organic matter, and it took more time than what we had to examine that. But it's a thought, and there'll be people here on the call that will have more thoughts about that than I do.
I would just mention from the research department that the off-calf program right now is looking and testing biochar. It's a big part of the program that moving forward. So there will be some of it information becoming available with that soon. Did anybody else want to answer the question or have anything else to ask? I don't see any. I have one question. It's 10:30 and we're going to break for 15 minutes, but I was just wondering about the contours at Huronview and the micropores that you have been talking about. And is there any, landscape management happening in terms of BMPs to deal with some of those things? It looks like Huronview, maybe the runoff, was it on a natural hill, or all of the contours were created to create a water catchment? Just, can you talk a little bit about that?
So the contour drainage is put on such a slight slope. There's just yeah, there is there's a slight slope, only 0.1% grade that we're putting in the tiles, whereas the pattern tile that's in the main field is at about a 7% grade. So, and your question is related now more to the nutrient pathway with the macro pores that
Yes.
develop in a no-till situation. So I would have to spend some more time looking at that, but I would suggest, because Rick, and he's the farm manager, maybe he wants to jump in too, with the little bit of tillage with the strip tillage, that might be
Might
one of
offset
those
it.
things, yeah, that is
Okay.
mitigating that trade-off. But certainly, like, I think when we do a presentation like this, we come away with more questions than we have answers for. But
So
I
I'd agree with them.
appreciate the thought, and I'm just kind of gears are shifting in my brain about how you would actually measure that. But if
Yeah.
it can be measured, we'll give it a try. Thanks, Kelly. And thanks for the question.
Well, and thank everybody. There's more and more questions popping into the chat box. I think what we're going to do is we're going to take a 15-minute break so that we can stay with our program. I'm going to invite our panelists to answer the questions directly and just make sure they go out to everyone, because I think it's beneficial for all attendees to see what the answers are. And we will come back in 15 minutes with the taking the 4R nutrient approach at 10:45. Thanks so much, everybody. Okay, welcome back, everybody. I'm hoping you can hear and see me. I am Kelly Carmichael again, the Knowledge Mobilization Specialist at the OSCIA. And I am your moderator today. We're starting our second half of the ONFARM Applied Research Forum, and we will pick up where we left off. We're going to invite Emily Cook from Sylvite to give us a great presentation on taking the 4R nutrient approach. Emily, do you want to share your screen? Fantastic.
Perfect. Can you guys see my screen and hear me okay?
Looks great. Thanks.
Awesome. Thanks, Kelly. Hi, everyone. Yeah, I'm Emily Cook, an agronomist with Sylvite in Kent Bridge location. Sorry, did I do here? Shoot.
Do you need a second?
Yeah, just 1 second here. I'm gonna redo this.
So your screen sharing has stopped and we can see you.
Yep, find the button to go back to it.
Okay.
Oh, here we go. Let's try this again. Sorry.
No problem.
Can you see that now? The full screen?
Yes, perfect.
Okay, perfect. Sorry about that. Yeah, I'm excited to talk about the 4R nutrient management approach today. So I just want to start with the definition of sustainability. It's the ability to maintain or support a process over time and or meeting the needs of the present without compromising the ability of future generations to meet their own needs. We need to use the 4Rs to help sustainably support the resources we have, use the investment of inputs effectively and efficiently, and also protect the environment. I like this quote here because it speaks to how we use something today and the impact that it has on the future. It's talking about phosphorus. Phosphorus is needed in many aspects, crops, livestock, people, we all need it to live. If reserves run short, yields do too, and there's no replacement. It isn't like nitrogen where we can pull more of it out of the air and make more product. Kind of what's in the ground is what we get, so we need to manage how we use it. Over applying can be a loss to the environment and also a large expense. There are a lot of risks to how it is used as well, such as economic, agronomic, and regulatory. Economic risks could be price volatility, agronomic risks of over or under applying it, and regulatory risks of if it runs off into water supply. Yeah, so this is just an example of phosphorus, but the analogy can be made for many other things, and it shows how sustainability is an important role. Some ways to implement sustainable practices are soil testing regularly, applying it in the right place, and protecting what you do apply. 4R nutrient stewardship doesn't just mean the 4Rs, and it's not just social concerns either. It also means a balance of economic, environmental, and social concerns, and having all of those working together. Farmers are already implementing 4R approach, whether they know it or not. Every decision is part of it. What fertilizer do I use? How much of it do I apply and when? It's all about managing the risk. This isn't just about rules or public pressure. It's also about balancing three things that every farm already juggles: the economics of the input cost and ROI, environmental with keeping our water clean and nutrients where they should be, and also social, meaning having trust in the public. If one of these things falls out of place, you don't have a complete system. So the 4Rs are the right source, at the right rate, the right time, and in the right place. So the right source could be stabilized nitrogen sources, products that are more available to the plant, products such as Aspire or Mez that deliver micronutrients more consistently, And there's a new phosphorus products that are more plant available and not water soluble. I'll get into that on the next slide. Right rates are using realistic yield goals to establish nutrient removal rates, soil testing, and using variable rate applications. The right time can be crop dependent, split applying nitrogen to crops when utilization rates are high, like applying more nitrogen later in the growing season. If we can apply the necessary nitrogen at the right time and the right rate, the hope is that we can see improved yields with less nitrogen loss through leaching and volatilization. The right place could mean strip tilling, starter bands, putting the fertilizer where it will be most efficient. So the more efficient phosphorus source that I spoke about the previous slide, it brings some excitement with it. It's called Crystal Green, or now CGP2X. It's a non-water soluble phosphorus source called struvite. It's only broken down by organic acids, which is released in root exudates. This means that even in soil moisture, the product does not break down like the traditional phosphorus sources. And if it's not used in the year of application, it will stay in the soil until a plant root reaches it and demands nutrients through the root exudates. If this product were to run off into water sources, it would have no effect since it does not break down in water. The plant availability of the phosphorus in Crystal Green is close to 100%, whereas other sources like MAP are more like 20% or so. The analysis is less than that, but with much more plant available for phosphorus. This is a great example of the right source. Another example of the right source is a nitrogen stabilizer. There are lots of them in the marketplace, some that reduce volatilization, some are just for leaching, and some that cover both. A product that we have at Sylvite is called Siloc Plus, which protects the nitrogen from both volatilization and leaching with the DCD and NBPT. It can be used with urea, UAN, manure. There are also products such as ESN that are slow release products. 4Rs use best management practices to aim to maximize crop intake and yield while minimizing nutrient losses. The 4Rs do not have to be difficult. Even by implementing simple best management practices is a way to get started. You can start by soil testing, knowing what's in the soil bank and what you have to work with. We need to use realistic yield goals to better determine crop removal rates. Use calibrated application equipment. Documentation is also very important so you can analyze results from implementing different practices and make changes if needed. Nutrient utilization versus losses will lead to increased profitability as well. I've mentioned some of these already, but some best management practices include soil testing, which will tell you what nutrients you already have or don't have, and you can make a fertilization plan around that. If your soils are testing low in nutrients, you know that you'll see a higher response to nutrient application. Whereas on the other hand, if you are testing high in some nutrients, you could potentially use some of that soil bank and not apply as much fertilizer. We just like to be careful with phosphorus applications. Weather plays a big part in this. Ground conditions are also important. So applications of phosphorus on snow-covered or frozen ground are not to be recommended. Also times right before a heavy rainfall. You can band, inject, or incorporate to protect the phosphorus, as well as other nutrients. Some of the practices you implement can be large capital investments, such as strip till machines. So creating a plan takes a lot of time and thought, and sometimes some money too. Using cover crops, they can be as simple as red clover or multi-species mixes, depending on your rotation, tillage practices, and crop protection practices. More about phosphorus application, be aware of when, where, and how you apply it. Like I said before, banding it, incorporating it, or adjust the timing of application. They're all examples of that. There's a social responsibility aspect to it as well, like I mentioned before. The general public is becoming more aware of the water quality. So when you get some green algae on the boat when people are out on the water, they get upset, which is, yeah, understandable. When a toxic sludge forces the shutdown of your drinking water supply, people pay attention. So just trying to reduce emissions is just good business when you're ensuring that the money you spent on nutrients is not gassed off or lost down the tile drain. Silvite has the majority of its sites 4R certified. The Kent Bridge location was the first one to be certified in Ontario. And that's all I have today. Thanks for listening to the importance of the 4Rs and what we can do to implement them. If anyone has any questions, I'm happy to answer them.
Thank you, Emily. We really appreciate it. And it's a great setup for our next session as well. It really feels like in terms of implementing the 4Rs, you need to sort of develop a schedule of practices that you do it at the same time. Is that right? Like not necessarily when you apply fertilizer and that, but when you're testing or how you're making those decisions. Do you have some?
Yeah, for sure. Yeah, soil testing at the same time every time kind of helps you make that relationship, I guess, from soil testing the first time to the second time. Like say, a lot of people, like say you have a corn, soybean, wheat rotation, maybe soil testing after wheat harvest every rotation. That way it's at the same time of year, it's after the same crop, just to kind of keep things consistent.
Okay, that's what I figured. Do farmers have a sort of calendar or some type of worksheets or something that they work from, or is it just every farmer has his own way of keeping track of all of these things?
Yeah, I would say it kind of depends on each operation. Some people are a little bit more involved with those kind of schedules, and other people are, I guess, a little bit more reliant on their consultant just to keep them reminded of when it needs to be done.
Right. Yeah, I don't think you mentioned consultants as much, but that's an important factor as well. We have a question in the chat, and it says, if we apply a biofertilizer product containing NPK and other nutrients, will it be considered as a right source as per the 4R nutrient strategy?
I think it could be. You just kind of have to look at what nutrients you're applying. You don't ever want to over apply. Kind of like I said before, we want to make sure we're using the nutrients that we put down. So kind of like a manure stance, I guess. You kind of have to look at all the nutrients that you're applying, some nitrogen, some phosphorus, and when those nutrients will become available. So typically in the year of application, you can have some nutrients more available, and then the following year, maybe some of the other nutrients become more available after that. So you just kind of have to look at the total amount that you're putting down, and then how to kind of keep that in the soil and protect it.
Okay. Are there any more questions? Anybody? Let me just look in the Q&A. There's questions are coming in through the chat. So Jeffrey says, great for our presentation. Raising the CEC of the soil would have a great impact on nutrient use. Unfortunately, many soils in Ontario have become very low in permanent carbon holdings. Carbon became the sponge to hold onto the nutrient supply. Do you have any comments related to that, or?
Yeah, like you said, the CEC has a big role in holding nutrients in there, as well as soil tie-up has some nutrients tied up there. Depending on your pH of your soil, if you have a low pH, it might be tied up with some aluminum. And if you're up into the higher pHs, you could have nutrients tied up and maybe onto your calcium ions. But yeah, CEC and carbon play a big role in holding on to nutrients for sure.
Do all farmers know what they're looking for in terms of soil testing when they get their results back and what they're aiming for in terms of their crops?
Yeah, I would say it also depends kind of on each person, but I would say 100% not everybody knows even much about soil testing. Some people are still just learning about it. Others have been doing it for 30 plus years. It just kind of depends on how they have been informed of things, and I think it's becoming more attractive now, especially with fertilizer prices the way they are. You can kind of lean on your soil a bit more if you've got some high testing soils. But yeah, I would say that it's becoming more popular, but there's still lots of people that need help guiding through the whole process.
Great. Yeah, I can imagine. Is there, I know lots of farmers, some farmers test their soil once, some farmers test their soils a few times through the season. Is there a general rule of thumb that you suggest in terms of how often when you should test your soils?
Yeah, so for the 4Rs, they typically say between 3 and 4 years is the maximum. So you kind of want to, it kind of fits into rotations depending on what your rotation is. But I would say, yeah, at the least every 3 to 4 years, we should be retesting.
Okay. Brad's asking here, is there any data on Silock stabilizer for a comparison?
I don't have any rate at my fingertips right here, but I know we do have some just comparing different products. Like I think we have one maybe against Agritane or something. So I can try to find that information and maybe pass it along to you, Kelly, so that you can get that
Sure.
out to whoever's asking. But yeah, I think we have some comparison data.
Okay. And if you have a link, if you happen to come across it before the end of the session, you can drop it in the chat to everyone as well. Again, I think everybody benefits from more knowledge, so that would be
sure.
great. Jeffrey says, yes, aluminum is everywhere and low pH unlocks it. Well water in Ontario is full of calcium carbonate, which can lock up sulfur, P, and K and reduce yields during flower stages. So that's good information. I don't know if you have any comments on that, but
yeah, just pH has a lot to do with nutrient availability for sure.
Yeah, there's a lot to know, obviously. Okay, I don't see any more questions in the chat, so I want to thank you again for this overview of the 4R management system. Again, people can contact Emily at Sylvite if they want to know more about it or want to get started doing any testing. I realize. Sorry, I was told earlier that I didn't have my video on. I apologize that for you're just looking at my black screen. So I think we'll move on to the next presentation, and we will invite up Don King and Margaret Rivey from the Soil Resource Group, and they also have two cooperators with them, Larry Dick and Kevin Isis, who will talk a bit about what they're doing on their farms in relation to this session, which is called Quantifying Soil Health Changes, Challenges, and Successes by the Soil Resource Group. All right, and I see a presentation up here, so that is fantastic.
There. You can hear me okay?
I can hear you. Yep, perfect.
Thank you. The Soil Resource Group is partnering with Soil and Crop, as you've heard, in delivering the soil health research and monitoring pillar of ONFARM. As an overview for today's talk, I'm going to be covering the background and soil health framework that we're following, an update on some of the results of the soil health indicator assessments, some overall observations across our sites, and Margaret will then investigate some of the site-specific findings with the help of a couple of our cooperators. who will comment on some of their own challenges and successes. So today we're going to be talking about a new topic, soil health, which I say that jokingly because it doesn't seem to be a meeting these days in agricultural circles that the topic doesn't come up. And that's certainly for good reason. Most farmers recognize the importance of looking after their soil, and how they can recognize it depends a lot on what they can see. Some of those visual indicators of good soil health are not large clods of compacted topsoil that you can bring up with a shovel. But it's things like smaller aggregates that you can break up from the topsoil. It's having a full soil profile with room for root growth, earthworm middens at the surface as an indication of biological activity. And to some, they'd suggest how much crop ends up in the bin at the end of the day is really a measure of soil health. So since the start of OnFarm, there has been increased interest in identifying what is soil health. But simply put, it's how well soil functions in providing a supportive environment to produce a good crop, while at the same time protecting the environment. How best to measure it from a commercial sense is an ongoing effort, and OnFarm, and along with a number of other programs like the SHAP test and the Greenbelt Foundation investigations, they're all testing different indicators of soil health and gathering some valuable data sets to evaluate these questions for farmers in tailoring a soil health test for Ontario. We began OnFarm with a list of recommended tests, both laboratory and field-based, and they can be lumped into carbon-based, nitrogen-based, and physical indicators that represent physical, chemical, and the biological components of soil health. We've revised the list along the way and finding some challenges with some of the tests' replicability and their variability. Yield is certainly an important check in a soil's ability to function. We're also doing an economic cost-benefit analysis of the use of the BMPs. But certainly it's our opinion that critical to the interpretation of soil health is the pedology assessment, where we're relating soil types and profile, texture characteristics, the natural drainage, and what soil degradation there might be for a sampled area. For context, our own Dr. Ann Huber uses this figure, and it really looks at the relative size of the soil health indicator tests. So certainly beginning with the soil organic carbon, it makes up a little bit more than half of organic matter. Active carbon as a test is only looking at about 1% of that organic matter. And that's really the available portion of carbon that bugs can use and turn over. And further, the Solvita CO2 test is that respiration test commercially available that looks at the level of microbial biomass activity. Again, as you decrease the size, you're obviously being able to get results that may be more responsive to change, but as a result, you're also becoming probably more variable in the results. And with the organic nitrogen pool, which is a much smaller portion of organic matter, certainly you can see that ACE protein makes up a fair chunk of that organic nitrogen. SLAN as a test is, again, a Solvita commercial test looking at the nitrogen portion. Again, measuring a very small part of that ACE, and in turn the PMN, or getting at what is becoming available to crops during the season. Again, that's a very small part of the total nitrogen pool. So understanding that there is this increase in responsiveness that's balanced with the idea that there's going to be an increase in variability. So for the on-farm investigations, these measurements really boil down to answering some key questions to better understand how well these indicators work, to show an improvement with the use of a BMP across a wide variety of Ontario soils and cropping systems and climates. As well, what key soil degradation problems that may be seen across these fields, and how effective that might be with BMPs to alleviate them. So to do that, the soil health monitoring is being done at both the CAs, so the edge field sites, which you can see here in blue, and the network of BMP trial sites. So to identify some of the key indicators for the Ontario soil and landscapes, the network was selected for some experienced cooperators and their field sites that are regionally representative of the predominant soils and landscapes. And furthermore, with the second round of ONFARM starting in 2023, the 25 sites were rejigged again a little bit to expand the number of regions, and now we're including 2 sites in northeastern Ontario within the intensively cropped Little Clay Belt. At each of the on-farm cooperator sites, the plot design follows an approach where we identify the 3 landscape units of lower, upper, and mid to capture that variability within a field. They differ often by soil drainage class and soil type. The cooperators themselves work with SRG to develop side-by-side treatments that align with the width of things like the cooperator's equipment, and also reflect each of the farmer's operation and their soil health goals. So looking closer at the site makeup, this is an example of Norm Lamasse site in central Ontario. Each site compares BMP treatments, either cover crops or organic amendments, or both in combination under conservation tillage systems. The sampling locations established in these zones and each of the strips are referred to as benchmarks. Composite sampling is done in triplicate at each of the benchmark locations for soil health assessment and agronomic monitoring. And this is important because it allows for statistical comparisons between the treatments, between the soil landscape zones, and in determining where there may be a combined effect of both the treatment and landscape position. Most of the sites, we began with a 3-crop rotation back in 2020 that began with wheat. So many of the sites in 2025 were in beans going into wheat, but several of the sites established an interseeded cover crop, some using a drone into corn, or in this case at Sean Mackey's site at New Lisker, into his spring wheat in August. Harvest happened in September, and you can see the level of growth of those cover crops in about mid-October. Certainly with the dry conditions in the fall, it was a challenge here to get cover crops established. And as it is in most regions where weather can limit the growth or prevent seeding the cover crop after harvest, having enough time to get good biomass and carbon accumulation is a critical goal to have a significant influence on the condition of the soil, whether that be structurally in the case of compaction, or for our interest, the impact on carbon, nitrogen, and the biological indicators. Monitoring across all the sites each year includes the soil sampling of benchmarks in June, monitoring of BMP applications, the cover crop biomass accumulations. This year we included SHAP analysis for most of our sites to compare some of the test methodologies. The agronomic monitoring of crop growth, sometimes hand harvesting happens just before the combines, and the crop processing. So the large database that we're developing of the different treatments is compared statistically for annual and cumulative BMP impacts within a site and between sites. So in assessing the indicators, consistency of the measurement is really an important consideration. So as we know, soils can inherently have high spatial variability, and at this sampling scale, using the triplicate measurements, they are meant to minimize those differences. So variability of the triplicate sampling results are shown here over the last 6 years of sampling across all of our BMP trial sites. So the coefficient of variation is calculated from those 3 samples or triplicates around each benchmark, and then that's been rolled up for all the sites. So starting with organic matter, certainly we're seeing some fairly consistent results around that 6% CV. The active carbon has been acting fairly similar to our organic carbon and organic matter. The commercial respiration test of Solvita, and along with a SLAN test, they started out quite well, and we were quite quite excited about them. But with time, we found that there has been some difficulties with the use of the commercial readers, and the replicability has been more of an issue over time. Using one reader over another gives different results. So we're a little less excited about that application. ACE has been something we brought on in 2022. It's the protein test, protein nitrogen, which again acts similarly to organic matter. PMN has been highly variable, and even within the small area that we're sampling with at a benchmark. So aggregate stability was relatively high with lower variability. Bulk density was similar as well, and surface moisture, not surprisingly, as expected, would differ a bit more. So as we evaluate these indicators for their commercial use, including how a farmer might utilize them, certainly the reliability of an indicator includes its variability at this same location. So we want to be within a certain acceptable range, and looking across the different indicators, I think we're finding some that are certainly providing better results within that 10% coefficient of variation. So in addition to knowing how the indicators are behaving in a small area, OnFarm's looking at the differences across a field and across sites. Some of the obvious hill slope differences shown here in the top right at Matt Bowman's near Uliskard is quite different than many of the sites that have more of a subtle difference in elevation, such as the one Scott Banks is establishing here in the spring at Warren Schneckenberger's in Eastern Ontario. So I'll ask you just to lean in a little bit here, but this is a box plot figure, and it's taken from the Soil and Crops website's online tool. So that's available for farmers to compare values from their own on-farm data sets. And anyone can go on and do some revisions of site selection or region and so on. So when we look at the organic matter as the first example, regionally there are differences that come out. And certainly broken out by landscape positions. So differences are reflecting a number of factors, such as the one in Eastern Ontario, where these higher levels are really a reflection of its history in having longer livestock management, a cooler environment, and those are combining to contribute to relatively higher levels in organic matter. The coarser soils we see in central region, they're also contributing to perhaps lower levels overall. As well, we don't have the northeastern area up online yet, but I just threw in those averages just to show in comparison they're not quite as high as the east for a number of reasons, and what we've gathered in doing our work in that area. There's certainly a large historical impact due in part from the methods of the clearing and leveling that went on when the land was first converted to agriculture. So interesting. But certainly what's obvious at any region are the significant differences found between the lower and the upper elevation areas and within the field. So in evaluating soil health, we need to consider soil texture, obviously. Firstly, looking at organic matter, the levels range largely by clay content, with lower clay content, coarser soils being naturally lower in value. You can see certainly in the sandy locations. The dominant effect of landscape position is again clearly shown. It's not only for organic matter. We see similar results for active carbon. For the ACE protein test, the texture differences of the coarser soils are partly overridden by some of the differences in position. So as a test, it may reflect factors that are contributing more to those differences in overall soil condition. So when we go to the aggregate stability test, as mentioned, it's relatively high across our sites, being a little bit less variable, and even within landscape positions. But there may be those physical limitations for aggregate formation on the coarsest soils that are showing up here. So when we look at the influence of landscape a little more closely across those indicators, this really shows the relatively greater levels that we do see at the lower position than the upper. So this is showing the percent of these indicators that are above our lower position. And we can see better how some of these indicators compare to the known differences of organic matter. Certainly, what is an underlying factor to these differences based on the soil conditions that we've seen across our sites, and tillage erosion is a factor that's observed in all of our landscapes and soil types. It's evident by decreased topsoil depths and rooting zones, the mixing of subsoil and topsoil, and decreased yield potential in these areas. So I think in verifying some of these known factors of region and soil type and position, the level of these inherent differences between indicators that are being monitored helps to better understand what we can expect and what may be a measurable change with a change in management. So what impact do BMPs have on soil health indicators? To take a minute, I guess in our previous meetings of the forum in 25 and 24, we certainly were able to show some differences statistically relating to the type of BMP, the intensity of the BMPs, the landscape position, such as seeing changes at a mid position being more likely than an upper position, just because we have more severe degradation in areas that may not see a change with a better management. But I guess I wanted to take a step back and look at, okay, so after 5 years of implementation of these different BMPs, if we were to roll up the results across our sites, can we compare those with our baseline levels to see much difference? So when we began sampling back in 2020, prior to the BMP treatments being implemented, the baseline indicator levels across the trial sites were starting at quite a variable level to begin with. We had quite a range, certainly. But the plot graph here, the box plot graph, shows a difference between our check and those strips that were in each of our three BMP combinations. And just as a quick overview again, when we're looking at this box plot, the box itself is capturing about 50% of our points. And so the median, that line in the middle, is really the middle of our points. So 25% of our samples are lower and 25% of the samples are higher. With a smaller box, then that suggests there's less variability and a closer match. So I think one of the things that does pop out, obviously, is this higher variability we're measuring with a couple of our tests, certainly within SLAN and PMN. That makes it more challenging to measure a significant increase with BMPs. So in looking at which of our indicators are more related to organic matter and some of the other indicators, and maybe possibly soil function, we look closer at a subset of these and compare that to where we are now. So again, looking at those indicators with lower variability and using an average difference between our check and each of our BMPs, so that vertical dashed line would suggest the values are similar or the same as our check. But we do see some separation, obviously, just in that background assessment of where we are comparing those treatments to begin with. In comparing that to where we are now, given that we don't have statistical differences to show across all sites, we do see some interesting things coming out, though. So with the cover crop treatment itself, those ranges are tightening up a little bit just to be able to show differences between our treatments. The organic matter level hasn't changed too much. Ag stability numbers haven't changed too much. Active carbon as you see at the first year's sampling, started out a little different. And there's some postulation of why that might be, but at any rate, we do see this decrease in carbon in that active pool. Whether that's a reflection of what's going on, I guess one offered explanation is that certainly with the use of cover crops, we have an initial stimulation of microbial biomass population. It may reduce that available carbon air pool. And so in contrast, when we're adding carbon with an organic amendment, we do tend to see an increase with that cover crop over that cover crop treatment by itself. So really, we're looking at findings that are showing a change between our different BMPs as you move across from just using a cover crop to including the addition of organic amendments. We see increased levels of organic matter overall. Ag stability is moving in that same direction. Although not statistically different than what we began with, we do tend to see these movements from just using a cover crop to the addition of organic amendment and the combination. The ACE protein, as I mentioned, we brought on in 2022, and it closely mirrors and reflects what we're seeing within an organic matter pool. So I think certainly the findings are providing some additional insight into not only the spatial variability across the province and within a field, but some of this temporal data of how fast or slow we might be able to see changes are an important consideration going forward. So I think to discuss some of those considerations a little more closely and at a site scale, I'm going to turn it over to Margaret, Larry, and Kevin, who's going to look at some of the site-specific analysis.
Okay. Let me know when you see my screen. I think it should be up there now.
Yeah, I can see it.
Okay. So just thanks, Dawn, for introducing some of these concepts that we're going to cover in the case studies. So first case study is Kevin Icey's property up in Oro-Medonte or Simcoe County, and so that's considered our central region. He is on a coarser soil type in that area, and his rotation in the on-farm plot has been barley, soy, winter wheat, corn, soybeans. He's looking mainly at the suite of BMPs. So he's got the cover crop, organic amendment, and then what we call the combination treatment, which is both cover crop and organic amendment. And those cover crops are typically being planted in the fall after a cereal crop. And organic amendments are in the form of a municipal compost and more frequently going on in the fall with one spring application during the course of the study so far. And I should mention that Kevin purchased this property just recently, probably around similar timing as starting this project. And he would note that the condition he received it in was not a good soil health condition. So just looking at the pictures here at the top corner, that's his field looking from the back towards the headlands. And you can see there's some rolling topography there. Looking at his organic amendment application, we've got the side-by-side with the cover crop treatment and the control in that middle photo, and then just a picture of some of that biomass accumulation and in the fall for sampling. So we're going to dive right into the data. Dawn mentioned that we maybe look at the indicators with less variability more often than those with more variability, or maybe we put more trust in them. But anyways, we accept that changing soil health indicators takes time and intense BMPs. So what we're going to look at through these examples is comparing the control to what we're considering that intense BMP. And so at Kevin's site, that is this organic amendment and cover crop combo treatment. So just looking at this first graph, we have our treatments across the x-axis, soil organic matter on the y-axis. The green data bars are where we started, so that benchmark baseline, I should say, data that Don was talking about. And the blue bars are the 2025 data, so from this past season. And when looking at the statistics, the uppercase letters can be compared to one another and the lowercase letters can be compared to one another. So in 2020, we did an ANOVA analysis on the difference between these treatment strips. Given that was our baseline year, we wanted to know, are they different to start with? And just focusing again on that control and combo treatment, we can see that they are not statistically different according to our ANOVA analysis. In 2025, the data was analyzed using a covariate analysis, which is a different analysis in that it takes into consideration that baseline or benchmark year, as well as considering the experimental design elements, which were landscape position, the BMP treatment itself, and then, of course, the interaction of those two, the landscape and treatment, and how those might be influencing, in this case, soil organic matter. So the interaction was significant at this site. And when that happens, you have to look closely at the benchmarks and see what each benchmark is doing. So in the case of Kevin's soil organic matter in 2025, at each landscape position, the organic matter was higher in this combination strip than in the control. So for simplicity, I've just put it on this graph so that you can see it. And as you can see here, we have that statistically higher organic matter in that combination treatment. So the second graphic here, it's the same setup. It's the ACE protein measurement, which is a nitrogen-based indicator. The green bars are actually 2022 data. As previously indicated, that's when we started to measure ACE protein. And again, just focusing on the letters of the same case, they can be compared to one another. So the same analysis was done in that baseline year, those green bars showing that the control and the combination treatment were not statistically different in ACE protein. And again, the covariate analysis was completed. However, what it indicated was that the BMP treatment was indeed significant, had a significant influence on the ACE values that were measured, not the landscape and not the interaction. So on this bar graph, you can see again, here we're seeing that a significant difference between the control and the combination treatment in those blue bars. So at this site, it does appear that the organic amendment and cover crop are creating a significant change in some of these indicators, specifically organic matter and ACE. So those are really exciting results, and we get, that's a positive movement that we were expecting. But it begs the question, what are these indicators doing in the other years? So to show how these change over time, here is a graphic of active carbon, and keep in mind this was one of our least variable indicators. So what this graph is the difference between the active carbon measured in the combination treatment strip, subtract the active carbon measured in the control for each year. So this is our baseline year here and up to 2025, this past growing season, active carbon again on those y-axes. So what you can see is, yes, we started off with about 100 ppm difference or a higher level of active carbon in that combination strip. And that is one of the difficulties or challenges with field scale research. However, if you look at it, the amount of difference between the combination and the control increases from year to year. And that's kind of what this line here is showing. So some years, the difference between the combination and the control was statistically different, and in other years, it wasn't. And that's one of the challenges with using these indicators to detect change year to year. So the benefit, however, of this research is that you can track these changes over time and gain an appreciation for how dynamic some of these indicators can be. What is encouraging is that this data matches the infamous squiggle graph, which shows what we can expect from soil health data over time. It changes from year to year, but it should generally trend to increase with BMPs. And so here we are in year 6, and it's pretty uncanny how similar those are. So just to recap, at Kevin's site on this coarse textured soil that started in a poor state of soil health, we were able to measure changes in some of our 2025 soil health indicators with the BMP. So our next case study or site is at Larry Dick's property in Camden, Ontario, which is on top of that Niagara Escarpment. He has been farming this property for quite a while. As you can see here, this is his homestead, so it's right next door. It's a fine textured soil that he's working with, and he has a rotation of buckwheat, corn, adzuki, sunflower, corn, and soybeans. And I must say, Larry, I didn't ever think I would learn how to do the yield of a sunflower field, but I can add that to my CV now. So thank you for that. So the BMPs that he's been working with have mainly been cover crops. So he's drilled cover crops, he's interseeded, and he's broadcasted. So just circling back to his home farm picture here, that this is a relatively flat landscape compared to most agricultural regions in Ontario. And this picture here at the bottom, we have a picture of his drilled cover crop next to the control. Here's a photo of what those biostrips looked like. And then, of course, the interseeded cover crop into that standing corn field. So with this case study, we are not able to show you treatment differences yet. The following data is going to demonstrate how soil health indicator measurements are influenced by landscape position and the impacts of historical degradation, even on relatively flat fields after years of good management. It really highlights the importance of using zones rather than entire fields to track soil health changes over time. So we're just going to look at Larry's 2025 data specifically, given that it trends to be different or similar, sorry, from year to year. So same as Kevin's 2025 data, we used that covariate analysis to determine what in our experimental design was influencing the indicator, the BMP treatment, the landscape position, or the interaction of the both. And for the statisticians in the crowd, I'm going to be presenting these in the reverse order as proper procedure, but just bear with me. This is to tell the story. So the first graph we see here is the BMP treatment and soil organic matter in 2025. So again, there's our treatments along the x-axis or organic matter on the y-axis, and we can see here there's no statistical difference between the treatments at Larry's plot in 2025. Keeping in mind this is a clay soil with good organic matter values to start and a history of good management. So, not too surprising. The next graph shows organic matter at the landscape positions. So we do trend to see a higher level of organic matter in those lower landscape positions. But in 2025, those differences were not statistically different. In 2025, however, the soil organic matter was influenced by the interaction between landscape and treatment. So like Kevin's data, we started looking at the individual benchmarks to determine what was happening at that level. And so this is where we start our analysis. In the third graphic here, you can see I've plotted the 2024 soil organic matter on the Y and 2025 on the X, and this is strictly for a visual to show you that the highest levels of organic matter are coming from those lower and mid landscape positions. And I didn't show it here because it's fairly busy already, but when I looked at each of these points, there is representation from every treatment strip within the plot. So what that tells me is it truly is the landscape position that is driving the organic matter measurements more so than the BMP treatment, even on this, what most of us would consider a very flat field. So moving on to the ACE results, the same covariate was completed, and the analysis was showing similar results, that the interaction between the BMP and the landscape, the landscape was significantly influencing the ACE values. So to continue on the theory that landscape is dominating the effect, this graphic is your 2024 ACE against the 2025 ACE, just for visual sake. Again, seeing that there's more lower and mid landscape position values in that upper range of what we were measuring. So, and similarly, those numbers are coming from all of the treatments. So that to me suggests that landscape is dominating the effect of ACE results. And that's not surprising, because as Donna showed earlier as well, ACE often mirrors organic matter results. Just a little aside, however, about ACE, it was interesting in 2025, the ACE measurements were statistically different between the landscapes, unlike organic matter, which maybe suggests it's a more sensitive indicator to differences. So getting back on track, this landscape effect that we're just showing you is occurring at many of our sites, making BMP treatment differences challenged to measure. This difficulty is obviously compounded, but what we know is that these indicators change from year to year. So in this graphic, it's similar to what we showed you at Kevin's. That's the cover crop treatment that had the most biomass accumulation, which at Larry's is treatment 1. And we're subtracting the control values, the active carbon control in the controls. So again, you can see that these are different from year to year, and in some years they were statistically different, and some years they were not. Again, there's a squiggle graph, so we're at least it's tracking the theory. So to recap, the soil health indicators at Larry's are not measuring treatment differences yet, which could be attributed to the dominant effect of degradation across the landscapes, even on this relatively flat field. So if we reflect on these case studies, a question could be, if the indicators aren't often able to measure changes in soil health from BMPs in the short term and are variable from year to year, how can we measure BMP improvements to soil health? So this is where we're going to ask Larry and Kevin from our case studies to provide us with some insight as to how they measure success from implementing BMPs on their on-farm plots and on their farms. So I'm just going to put the slide up here while Larry and Kevin get themselves situated. So just quickly, this picture here is this is the clay soils, and for some of us, this would be considered a heavy clay compared to what we're used to working with, and that's quite an impressive photo of his aggregate stability and rooting through that soil and under that cover crop. As well as we're seeing here, one of his practices are to plant green, and so obviously that's a crimson clover field in the spring getting planted into, and I think that just beautifies the landscape, and it'd be lovely if we could see that more often in the spring, in my opinion. Then moving on to Kevin Icey's property here, we see that he's got a really nice crop of soybeans coming in with quite a heavy residue cover, and as well as this incredible root on a tillage radish, which I think if I read that tape measure properly, Kevin, was about 2 feet worth of root there. So some success with what he's doing. So, Larry, I'm going to start with you, if that's okay. The first question, we aren't yet measuring differences in the indicator at your plot, but how do you measure soil health improvements over time?
That's been a really interesting question. And initially, I'd hoped that we'd see lots and lots of changes in the numbers. But for me, it's really come down to the fact that we're still farming. So we've changed our practices significantly in the last number of years. We were no-tilling beans and wheat since the mid-90s, but the corn, we were still in a full tillage program, and we're getting quite frustrated with how our soil responded to tillage. And so when this idea of planting green and into cover crops was suggested, we wound up throwing the whole farm at it. That wasn't our initial intention. That's just the way it worked out. And so for me, really the success and the measure is, can we farm doing this? Because there's a lot of benefits that other speakers this morning have talked about in much less erosion, tillage, water, whatever. So we're holding our soils, and yet we're able to grow crops doing this. So for me, that is a success. Whether the measurement numbers that we're trying to use to ascertain what we're doing aren't showing what we would like them to, the economic numbers are. That's fantastic that you can, suggest that the economics are working out, and that is one thing we are doing the on-farm project, is crunching those numbers that are provided to us in terms of determining if these BMPs are making sense economically. Just one other thing, Larry, I know that for some people, they may not fully appreciate your challenges of getting on your clay soils in the spring, and what has this planting green cover crop inclusion allowed for you to do when it comes to that frantic spring season? Sure. One of my concerns, we heard a guy speak in Guelph in 2015 about plant green, and I thought my understanding always was that my fields had to be bare and brown to plant into them properly, because how we depend on moisture evaporation. Even where we have tile drainage, we still need evaporation. And how could a field evaporate if it's got all this mulch on it? And that was a huge fear factor for me. So we've been doing this now. We're heading into our 11th season, and what became evident very quickly is that having a good cover crop there does a pile of transpiration. If I was to kill that cover crop ahead of planting, now it becomes a mulch mat and it can really hold moisture. But we have not found that we are delayed in planting at all from anyone around me. We're able to get out there and roll. We have had one or two situations where we've been able to push the boundaries and got some things planted when normally we wouldn't have. But under normal situations, we are able to run when our neighbors run. And I think it's because the cover crop is transpirating, if they're translocating moisture, and so we're able to roll. So it's not held us up at all. In fact, it's been a benefit because we're not trying to get some tillage passes in there ahead of it.
Yeah, no, that's great, Larry. Thank you for that. I was hoping you could kind of touch on the mechanics and logistics of it all for those that are thinking that might be the craziest thing they've ever heard. So moving on to Kevin, given that the on-farm plot was on a newly purchased farm for you, what is your approach to improving soil health, and what has worked in your systems and what hasn't?
But I like what Larry said about, the reason, the ultimate way to measure this is that we're still farming, and the economics of it are kind of the number one thing, putting that crop in the bin. So we have a dairy farm. This farm that we have this plot on is outside of the radius where we would be able to apply manure or have forages. So we come at this, seeing the benefits of those practices in a dairy farm where you have the livestock, the manure, the rotation, and those fields that are coming out of forages are yielding better. The soil is healthier. If I even step back a little further, we participated in the cost sharing in the environmental farm plan early days, and we bought a windrow turner composter. So we were able to compost our bedding and manure pack, and we really seen how that benefited the soil and the soil structure and the yields that accompany that. So our goal is try to replicate that. We talk about, Don talked about the chemical, the biological, the physical in soil health. That biological piece of it, we're trying to replicate in areas where we grow crops that don't have access to the rotation and the organic amendments. So we had been on these farms already, purchasing municipal compost, kind of your green bin stuff. We've had been incorporating cover crops, mainly after wheat. But other than the touch and the feel and the visual of the soil, we were really excited to be asked to be in this program, so we could actually see the data that the team is measuring, and it's gratifying that we are seeing results in those numbers. But also realizing that the farm that we're using has started at a point where the levels are quite low. So those gains of improvement probably are a little easier captured in our situation.
For sure. And that kind of leads nicely into my next question for you, Kevin, is like you indicated, you're touching, you're seeing differences. If you could maybe just more specifically let us know what you're seeing as you're walking those fields and as you're combining, et cetera, what other soil health benefits, other than what we can measure with an indicator, what are you seeing on the ground in terms of improvements to the soil health at your on-farm plot?
Well, certainly, and that those improvements we see in other systems that we're doing on our fields too. But just the use of that organic amendment, although it's not as superior as your livestock manure is in those strips, and then you layer the cover crops on it. We do see soil tilth increase. I know in our wheat system, we in our situation here, we've been drilling the cover crop in just to get a better stand, because I believe that's a better way to do it. But over a large acreage and the time involved with that, we have been just broadcasting some of our cover crop seed with some additional fertilizer. But we do see, especially in the spring, after that cover crop has died and started to decompose, we see yield weed suppression. We can no-till into that mat very nicely, and it's not as bold as Larry's with the green growing mat there, but we do definitely see in the soil the crops respond to that system.
Excellent. I'm wondering if I could just prod you for one more thing. I know you've mentioned, and this is something that was really interesting to me as in an agronomy vein, was your IP beans and what you're seeing there with these BMPs. And for those who maybe aren't aware, like IP beans get you a premium. So if you can do a good job at growing them, it's advantageous to do so. So I'm just wondering if maybe you could just briefly touch on what you're seeing with these BMPs and your IP beans.
Oh, for sure. So we on this site, we haven't grown IP beans just for the rotation in other areas, but our rotation is changing a little bit to achieve some of that economic advantage of the yield that we get out of planting into the cover crop residue with the IP beans, non-GMO. We are definitely getting superior weed control with the conventional spray program, and just that extra soil improvements really seem to benefit that crop, where usually sometimes the varieties in the IP world are perhaps a little less than you would get in some of your Roundup Readies. We don't find that at all. We're able to get those beans off sooner because they get started in good condition, and then often we're going back to wheat because of the timing that the beans are off early, and so we get a bit of a cycle that way going.
No, that's excellent, because I think that also speaks to the economics of that saying. So, but if you can include those premium crops in your rotation because of good soil health conditions, and the inputs into those crops become less expensive, and growing that crop becomes less expensive, the return or the ROI on that BMP looks a whole lot better.
For sure.
So the last question we have for you guys, I'm going to direct to Larry. Based on your successes and failures in building soil health over several years now, what advice do you have to those looking to making improvement to their soil?
Well, first of all, do something, and and to do it on a scale that won't sink you. We don't read a lot of it, but every once in a while, somebody will put an article out, talk about doing an experiment on 5 or 10 or 20 acres on a quantity that if you got zero success with this experiment, it wouldn't break you. But what would you learn? We wound up throwing the whole farm at it and had to fight pretty hard to learn what we learned. Our first year planned green, we had heavy drought. Learned a lot from that we wouldn't have learned if it had been good moisture. And so I would not, for the stress factor, I would suggest don't start with whole farm, but it can work. But start on an acreage that won't sink you. I've had those conversations, and with a father and son, and the son wanted to try something, and the father was reluctant. And I said, "Well, if you tried it on 10 acres, would it break you?" And the father looked at me kind of offended, and then he chuckled and he said, "No." I said, "So why not?" And so that's the big thing. And look at everything. It's a complete system. We're on our third different planter since we started this, just because on our heavy soils, we have to have a planter that will get in the ground. Lots of coarser textured soils don't need the down pressure that we do. But, do something, because the soil is a phenomenal resource, and it is eroding. It is in Lake Erie. It is in Lake Ontario and Lake Huron. It is running down our water courses. That's real.
Yeah. No, that's wonderful, Larry. And I think that kind of wraps it up as, just get started and be prepared to make changes. And that's kind of the reality of farming in general. So most farmers are probably used to that.
Yes.
Wonderful. So thank you both for joining us. I'm just going to move on to some of our take-home points from our presentation here. So first off, measuring changes in soil health with the use of BMPs is obviously challenging, and it takes some time, and it should be done in a combination of field and lab tests, because as you can see, some of our lab tests maybe aren't behaving as we may have expected or we're hoping, but in the field, as Larry and Kevin have indicated, we are seeing differences and improvements with BMPs. So the ability of a soil health indicator to measure change due to an introduction of a BMP is influenced by several factors, which I think we've alluded to now, which is soil type, the level of degradation across landscapes, and obviously whatever BMPs you're hoping to use. Measuring improvements to soil health with BMPs on coarser soils, such as Kevin's, that started off in maybe a poor soil health condition, likely would be taking less time than on those finer soils, like in Larry's case, that have been under maybe good management for a long time. Historical degradation, so that landscape effect we were talking about, reduces soil health indicators across all landscapes, even on those relatively flat fields, and can make measuring BMP improvements more difficult. So even though statistical differences are challenging to measure in the short term, and we're seeing that in our data still this year, trends and farmers' experiences suggest that BMPs are successfully improving soil health. So with that, we'd like to thank you so much for listening, and I guess we will move on to our next speaker.
Thank you so much, Margaret, Dawn, and Larry, and Kevin. That was an excellent presentation, just giving all of us farmers some real life testing and examples to build confidence for everybody to move their practices forward. And I really appreciate what Larry says, to just start small and do what you can. So I'm sure everybody's taking some great information away from this presentation. And with that, we're going to move on to our next presentation and our last presentation. It's gone by very quickly. And I'm really happy that Jonathan Zettler is here. He provided a presentation this morning at Mazek, so I know it's great to have him jump on here as well this morning. Jonathan Zettler is a certified crop advisor and the founder of Fieldwalker Agronomy Limited. And he's going to provide us with a presentation today on optimizing nutrient application rates with SWOT maps and exploring the new SWOT water tool. And this is going to be another great presentation. So I thank everybody for hanging around. And Jonathan, if you have some slides to share or want to pop on here, that would be great.
So I'm sitting in my truck. If I look kind of funny here on my background with the lighting for some reason, but
great.
We will share our, just trying to figure out how to navigate sharing and run this at the same time. So if you have questions,
oh, perfect.
If you have questions, just speak up as we go here because I may or may not be able to see what's going on. But the presentation I have is for the Fairview site with Lower Thames Conservation Authority. There's 2 fields that we get swap mapped in that field. One was swap mapped this fall. The other one was spring of 2024. And as far as soil sampling goes, both of them were sampled this year, just with manure applications on this field and a few things, just kind of how things had worked out. So as far as crop mix on this farm, the grower grows edible beans, typically white beans, and seed corn, so a bit of a different crop mix than what I'm used to, and makes some of his nutrient applications from liquid hog manure. I'm not involved in the crop planting piece, so if you have questions on that, not necessarily the person to ask, but can show kind of what we've learned from this field and possible use cases for using SWOT maps and SWOT water when it comes to making management decisions. So as far as the location of where this station is located and the field in question, so we have a Meadows Metos 300 with a Centec 120 centimeter soil moisture probe, and it's located just outside of Chatham, so you can kind of see in the bottom of my screen there is the approximate location of where this is located. And the weather station was, as far as the soil moisture probe, was installed about June 20th, 28th, somewhere in there, after the white beans were seeded. So as far as the SWOT water today, it's a very manual process in terms of putting soil moisture probes after seeding. In Western Canada, they're working on trying to find permanent solutions, which is a little bit easier for them because they have no-till as the predominant tillage system versus here with worked fields. So as far as the field location goes, it's one of the monitoring sites for the Lower Thames Conservation Authority, and you can see the station that is installed as this one here. The rest of the devices there are related to water quality monitoring for the Lower Thames at this site. So they're measuring tile outflow from the location, and this is an additional thing that's being measured at the site. So, and the farm is split into 2. So the west side that you're looking at currently was planted to white beans, and then the east side was planted to seed corn. So what are we trying to do with SWOT maps? We're trying to approximate nutrient response, and I kind of wanted to talk about the reason why we're even trying to manage based on landscape position, and SWOT map stands for soil, water, and topography. So we're trying to manage based on landscape position, and the presentation that Margaret and drawing a blank on her coworker's name at the moment, but had just given ties in quite nicely actually with this one in terms of what we're trying to do from a management standpoint. And what we're trying to do is approximate expected nutrient response when it comes to field variability. And what we're looking at here is a soil sample bucket as I'm ground truthing a soil map that we're going to use for a customer. And we're in zone 1, which is a knoll. And you can kind of easily see the bucket, and probably in this cover crop of oats, fairly responsive to nitrogen in this example. I like ground truthing these maps, so that's validating that the zones match the maps when cover crops are in the field, especially oats, because they're so sensitive to nitrogen. It will show very quickly where you have differences in mineralization rates, provided that there's not excess nitrogen left over from the winter wheat crop. And as you move into the lower landscape position, so this would kind of be a mid-slope position or zone 5 in the swap map system, you can see that there's a lot more nitrogen being mineralized in that landscape position versus zone 1. And then zone 10, which would be a water collecting depression, probably the oats are lodging, you have excess nitrogen mineralizing in those landscape positions, probably not overly responsive to commercial fertilizer or any manure applications, and lots mineralizing there on its own. So as far as building management zones to try and come up with adjusting crop inputs by landscape position, there's a number of issues with it. If we want to build management zones, ideally the same zones can manage multiple inputs. So whether it's nitrogen, phosphate, potash, seed, fungicide response, we kind of want to bring that down to a single map to make it easy to manage from a management standpoint. And it needs to provide a very clear visual indication of what your expected crop response will be. And the cost to doing this cannot exceed the expected benefits, because otherwise you're kind of in a negative economic situation. So this is kind of the lens that Jonathan looks at when he's making crop recommendations and looking for things to help. And regardless of what the status quo is, this may or may not be a fit for the individual farm situation, but I can use it to do directed scouting to assess seed mortality at a field level, and subfield level I can use it for seed scripting and trying to match some of these other things. So what is swap maps if you're not familiar with it? I call it an indexing system in terms of trying to index water movement and soil crop input response within the field. We always have 10 zones typically when we go to a field. Number 1 is the driest parts of the field, so your knolls. Zone 10 is the wettest part of the field, so the dark greens, and that's where your water collecting depressions are. The other way to think about it from a conservation standpoint is zone 1 has soil erosion probably leaving those areas either through wind or water possibly, or just pure gravity if it's tillage erosion. And then zone 10 tends to be collecting those areas, and zone 9 as well. So the map blends these different layers together. So there's a soil layer. Typically we use EC to help delineate that, a water layer and a topography layer, and then we break those out, whether how hard they either shed or accumulate water. So this is just putting the picture on the right there of zones in terms of topsoil depth to how we manage the different management locations. So step 1 of building these maps is to collect data from the field. Typically in Ontario, we're using LiDAR if it's available, or RTK elevation data with a base station. We include water flow and topography and electric conductivity to build these. The electric conductivity helps sort out the ability of depressions to either hold or shed water, and that's very key because from a water behavior standpoint, they behave very differently and should not be grouped together when you're building management zones. So if you're using topography modeling today and you're not separating those out from a behavior standpoint, you're going to get very different response when it comes to crop inputs. An example would be nitrogen. So if you're applying nitrogen to a field, the water holding depressions are much more susceptible to denitrification, for example, that versus ones that properly drain because they won't stay saturated. From a LiDAR standpoint, I just want to show that the elevation data that we are using needs to be very high quality. And the reason for that is we're essentially trying to model water at a 1 meter or less resolution level, and even cellular-based RTK, it's too streaky for us to work with to do a proper job of these maps. From an electric conductivity standpoint, there's multiple sensors on the market. In the last 12 months, some of these service providers are starting to fade a bit. Topsoil Mapper and the makers of the EM38 are currently in interesting financial positions, but there's a number of sensors out there that we can connect to build the map off of. So typically map the farm every 50 feet to collect close enough data to model what we're trying to do here from a water movement standpoint and just differences in soil texture. On the left is an example of one of my farm fields that I had mapped in 2018, and it just kind of shows differences in electric conductivity within that field. The dark purple are areas that tend to collect water, and the dark reds are areas that tend to shed water. But not all of those areas shed water necessarily or collect water at the same rate, so you need to include other areas and ground truth it to kind of validate that. So. From a ground truthing standpoint, the swap maps makers give us about 20 maps to pick from with different elevation models and electric conductivity models to ensure that it matches what we're actually seeing in the field, and we try and pick the map of best fit. Once that is completed, then we soil sample the field to my slides got out of order here. Sorry. We soil sample the field to. It's not necessarily as high resolution maybe as what grid sampling is, but what we're trying to do is approximate nutrient response in those different areas of the field. We're not necessarily trying to validate how much variability is in the field, which is a bit of a different thought process. From a fertilizer response standpoint, zone 10 tends to be an average yield potential type area, and but low fertilizer response if we're trying to approximate that depending on what nutrient we're looking at. And then zone 1 tends to be a high fertilizer response but low yield potential. So this matrix can help explain what we're trying to do when it comes to fertilizer recommendations relative to what the crop can produce in those different zones. As far as reports and prescriptions go, the program and system lends itself very well to include multiple inputs on a single layer in terms of coming up with the recommendation. The example here is for spring canola in Western Canada, but I'll show something similar later on in the presentation for corn in Ontario. One key aspect is understanding what your mortality rates are when you're coming up with variable rate seeding prescription recommendations. If you do not understand how much stand you're losing, it can become a bit of a futile exercise as far as trying to optimize what that rate should be. So here they've got an example of cereal, and for the most part, we're seeing about 30 plants per square foot. Zone 9 and 10 in this case in Western Canada would be a saline area, and they need to significantly crank the seeding rates to overcome seed mortality. In Ontario, typically, if we use corn as the benchmark example, seed mortality tends to be a little bit higher on knolls for a variety of reasons, and whether the field is tiled or not, if it's systematically tiled, it tends to be fairly uniform for the most of the field outside of the knolls, but on untiled ground, the depressions can have significant seed mortality compared to, say, the mid-slope positions. Post-harvest assessment is typically used to try and quantify lodging or just plant stress in general, where things are kind of at. So to to handle managing these management zones, the SWOT Maps folks have built a record-keeping system called SWOT Records to record all the data. SWOT Box is used to collect the EC data autonomously. You just mount it on typically a side-by-side or a pickup truck. SWOT Cam is a plant stand count system that gets mounted to either a sprayer or a four-wheeler to autonomously count plant stand counts. There is some restrictions around crop stage in terms of what it's capable of, but crops today that can do are corn, soybeans, wheat, potatoes, canola, as an example. And then SWOT Water is the water forecasting system that we use with at the site to kind of demonstrate expected plant available water within the field. Unfortunately, they're making some software updates at the moment, so I can't show any specific maps from this season on SWOT Water, but I have some examples from previous years if that's something of interest. So as far as the fields in question go, the east side of the field, I put the two maps together on the presentation here. So just draw a line kind of down the middle here. So the west side of the field was planted to white beans June 15th and harvested about September 20th. And the east side was planted to corn, seed corn, and then harvested mid to late September. So this is a picture of the white bean field in September, about September 15th. So you can start to see that it's starting to senesce a bit, but overall seems to be fairly even for the most part from that landscape position. As far as elevation differences in this field, when people are talking about flat, this is about as flat as it gets, in my opinion. Out of the 50 acres or 40 acres there, I have about 4 feet of fall over the entire field. For the area that I come from, it's quite flat. However, even with that little of elevation difference, when I ground truth this field, you could still see significant differences in soil behavior as far as how water flows within the field. And so this on the east side of the field kind of gives a 3D indication of what that field would behave as far as water and management zones. So the red areas are the water shedding areas of the field. The darkest of dark green are areas that water is going to accumulate, and then kind of the colors in between are the mid-slope position. So how do we use these to make crop input recommendations? So this is the east field, and in this particular case, from a seeding rate standpoint, if you were planting field corn, I'm not familiar with seed corn, so I'm not going to comment on that. But if we were planting field corn, typically your lowest seeding rate ends up being on the knolls just because of the yield potential in those areas tends to be limited by plant available water. The exception would be if you're on a soil type, if you had extremely high seed mortality in those areas, perhaps increasing your population may help overcome some of those issues. The highest seeding rates when we're doing corn recommendations tend to be in the lower landscape positions. Water's usually not limiting as far as a factor goes, so we go and put more plants there to try and take advantage of that. The zone 10s or the water holding depressions, we usually end up putting closer to maybe a field average as far as the seeding rate goes. Even though those areas are wet, surprisingly, they cannot support very high plant populations. And my speculation is that the rooting depth on those plants is very shallow. And if you run into a period with dry weather conditions and the water table is not at the root zone, they're not able to support higher plant populations. From a nutrient application standpoint on this field, the one thing I would point out is typically almost always, there are exceptions, but the highest levels of phosphate tend to show up. So these soil tests were sent to SGS in Guelph, and the highest levels of phosphate almost always show up in the lowest landscape positions. Probably a variety of reasons for that. Lower crop removal in those areas if you're doing flat rate nutrient applications. Water-soluble phosphorus likely collects in those areas is my expectation. And then also soil erosion is possibly eroding into some of those spots from other parts of the field, depending on how water is moving within the field. The upper landscape positions can either be highly variable as far as soil test phosphorus goes, and I feel there's a variety of reasons for that, partly due to yield potential, but also how much erosion is occurring in that area of the field relative to crop removal and nutrient applications. One thing I would say that I see consistently in almost every field is the mid landscape positions, especially zone 5-6 and possibly 3-4 or 7-8. It kind of depends a bit on the soil texture of the farm, but these landscape positions almost always have some of the lowest phosphorus levels on those fields, and I feel that it's because crop removal exceeds replacement in those areas, and we tend to see lower levels as a result. As far as potassium, this field has more than adequate levels given the numbers, but if from a fertilizer recommendation standpoint, typically tend to see either very high or very low levels in zone 9-10, and the knolls tend to be fairly consistent on the higher end, which is kind of surprising, even though we tend to still see potassium deficiency in those areas. And my guess is that the plants either pull water from lower areas that just don't have adequate supplies, or it's just not available to the plant. Zones 5-6 and 7-8, it's not unusual for those levels to be lower as well if crop removal is exceeding replacement. When it comes to the dry beans, if we were to write a variable rate prescription for dry beans on this field, what we're trying to do is increase the number of pods that the plant is able to set. You can kind of use some of the same methodology to soybeans, and usually we increase the seeding rate in those areas to try and pick up some of that. This can backfire on you, however, if you run into dry weather conditions at the wrong time and you have a lot of vegetative growth prior to pod set. You will unfortunately hurt yield sometimes in those areas, but you will improve canopy cover. So when we're writing these prescriptions, the idea is to play for 8 out of 10 years kind of thing. The lower landscape positions typically branch more with unlimited water. For the most part, plants are much growthier, and if anything, you want to cut back so that they don't end up lodging and trying to outgrow each other, and also reduce the risk of white mold. The lowest landscape positions really depends on how much root rot you have. Typically, root rot's not a huge issue with dry beans because of how late we're planting it. In soybeans, it tends to be a bigger concern. As far as nutrient applications on this field, some of my earlier comments apply here as well, with 34 being the highest phosphorus rate or test, I should say, and some of your lower phosphorus levels showing up at 17 and 18. Any questions thus far on the recommendation piece before I go into SWAT water?
I think there's Jeffrey has just put a comment in about the water zones have less oxygen zones for roots, creating anaerobic zones which breed harmful bacteria. This dropping of the pH of the area through metabolic waste and unlocking bound aluminum. So I guess something to consider. There's not a lot of other questions yet, but I'm sure they're coming.
Yeah, that's fine. So I'll talk about SWAT water in terms of the direction that they're going. I spoke with the main project lead on this. So this is still in beta testing. We haven't really used it in Ontario much because we're generally of the view that we're not water limited. However, I do have a number of clients that are looking at Rain 360 systems to apply liquid manure or to irrigate. And there is a few irrigation pivots starting to show up on farms in Ontario as we are trying to maximize crop production. So certainly an opportunity here to see what the fit is in a rain-fed system, I guess. So as far as the direction swap water is going, they're undergoing a number of software updates currently as far and moving from desktop version to a web version. So there's a few things going on there to try and move that over before spring and into summer. What they're looking at long term is trying to understand the relative differences in plant available water in the landscape. And the main project lead on this came from the University of Saskatchewan's environmental program, and he's trying to determine how big the differences are from the knolls to mid slopes to depressions in their landscape. The one challenge that we're having with these types of systems, whether it's swat water or other programs where we're trying to forecast plant available water, is they're very manual today in terms of installing the probe, pulling the probe back out prior to harvest or after harvest, and then installing it again in the spring after seeding. And it adds up to a lot of labor costs. So they're exploring today how to maybe have permanent soil moisture probes within the landscape in 3 different landscape positions to also kind of give a better feel for what's the driest part of the field doing, kind of the Goldilocks zone doing, and the wettest part of the field doing as far as moisture system goes. And then the goal is to hopefully forecast yield potential to help maybe with some management of crop inputs. Using soil probes in dryland agriculture tends to be there's certainly some interest in Western Canada to do that. Not so sure what the fit is in Ontario. We really don't make that many crop input decisions in crop necessarily with water-driven data today. The only one would maybe be adjusting your nitrogen rates or a fungicide application depending on the crop. Most of the crop decisions have already been made already up until that point, but perhaps if we can collect a database to kind of build out what the available water is on a few different soil types based on landscape position, we can fine tune our seeding rates and some of the other inputs that we're putting on. So I did want to show some of the data that the soil probe can collect and the weather station. So the soil probe that is on that weather station is 120 centimeter every 10 centimeters it collects. So there's 12 areas that it's collecting from, along with rainfall, solar radiation, relative humidity, leaf wetness, wind speed, as far as measurements go. So probably the one thing I would point out is that this orange line that's on the chart here, whoops, back one. The orange line on the chart here is at the 10 centimeter mark. So that's the shallowest spot that the soil probe is. And you can see that the rainfall events result in the soil probe going up as far as volumetric water content goes. So you can see that the water's infiltrating into the soil. It's not necessarily running off. And as all the lines kind of drag down to the right, that's just an indication that the root system from the plants is starting to access water as you go through. So as you go through the growing season, that's typical behavior that you want to see, is that the roots are starting to pull from lower and lower. The one thing that you do see a bit in this area of the graph that was pointed out to me by the weather station providers, that you see some stair stepping there, and that's just the pull of the water. And then as it goes into night, it kind of levels out again, and then you run into daytime again. It starts to stair step down, and that's again normal crop behavior. So this soil probe also can measure soil salinity, so you can kind of see if salts are moving into the lower soil profile or not as you get rainfall events, and it does measure temperature as well, which if you're trying to plant corn or maybe some temperature sensitive crops, it's kind of a nice feature to have to try and see if what's going on at those levels. The one thing that I found interesting is that we had some cool weather conditions in late August and into September, and it's interesting seeing how far those got pulled down when that occurred. So the one thing that this system can be used for is to trigger when to irrigate. It's kind of just trying to determine what your field capacity is and where you're at for plant available water. So the rule of thumb that you would do is kind of figure out how far the rooting depth is on the plant, group those soil sample or soil water pieces together, and then it can provide an indication of what your volumetric water content is in the root zone, and then forecast maybe when you're at the 50% mark, and you should probably initiate irrigation if that's something that you're working on. So you set field capacity at the maximum volumetric water content, and then you set the refill point based on the rooting depth, and 50% of field capacity is kind of what the rule of thumb is. So this is the example of some of that stacked data from the station at Fairview. So I grouped the first meter together and then set the plant available water as the top of the green line there. It's about 43%, I believe, or maybe a little bit higher that it kind of maxed out at. Take 50% of that roughly, and then you set that above the base kind of thing in terms of when to trigger irrigation. So I guess what this is saying is we probably didn't need to irrigate in that particular field. So one thing I did want to point out, this is what the crop looked like on August 26th. So fairly green, doesn't look too wilted from what I can see. And you can see that they had a bunch of rain events leading up to that, but it is drawing down around that period to pull moisture out as you head into pod fill. So that's kind of the main part of the presentation I had, unless you want to see some examples from last year of some of the SWOT water maps that we can generate with the system. That's kind of the main part of the presentation I had, if there's any questions at this point. So
I don't see any more questions in the chat box. I'm just wondering what the setup looks like. You were talking about probes for the water, and how do you set them all up? Are they permanent, or do they work with your SWOT maps as well? Like, how does that all
So
what does it look like?
they do feed data into the SWOT maps as far as SWOT water goes. So as far as the weather station goes, that's on the left here, and then we have a cord that runs to the probe, and where that pink flag is on the right is the probe in the ground. So you can't really see much of it, and that's why we typically try and flag it or put it right at the weather station so that someone doesn't drive over it or damage it. And then as far as install goes, use usually a gas-powered soil auger, or sometimes if the soil is agreeable, you can get away with the 20-volt or 18-volt cordless drill to put the probe in, depending on how deep the probe is. And it's fairly takes about an hour to install it. It's a dry install, so we're not making a slurry to go around it with this probe style. I have worked with other probes where we're making a slurry. So we oversize the hole, pour slurry into it to make sure that it's having soil contact, and then push the probe in after and scrape away the excess slurry.
So it's permanent, and it would stay in through the winter as well?
You can leave it in the winter. Usually we pull it out prior to harvest if it's an issue that the farmer may drive over it, or we just leave it at field edge and flag it and pull it out before any tillage. So we do have to pull it out between tillage operations, unfortunately. in Western Canada, when they're talking about possibly doing a permanent install, those are in reduced tillage systems for the most part. So,
Okay. Well, this is super interesting, and we really appreciate you giving us this. I guess it's a relatively new tool in our toolbox for monitoring soil and water. And to optimize costs, yield, soil health, and I guess ultimately to improve profitability. Do you have a lot of customers in Ontario that come back every year to do this, or how
I would
how is this
say
growing?
this is bleeding edge at this point, Kelly. So, as far as the water side of things go, there's certainly a number of customers that are running soil probes, not necessarily with swap maps, but certainly the functionality is there. So, Matos or PESEL is the weather station provider that integrates with this system, and the data from their field climate app flows into SWOT records via API, and then you
Right.
can set up the maps to automatically generate if that's something of interest. So it's kind of how that workflow is supposed to work today. So on the bottom there, there's volumetric water content, kind of a forecasted measurement. Today, what the practice is you put the probe in the mid slope if you're only going to put one in the field, and then it kind of calculates expected water content based on soil texture, a bunch of other parameters. So,
Okay. Well, that's great. I'm looking forward to seeing how this plays out with the on-farm program and all of the information that we can garner from it. Thank you so much, Jonathan, for joining us today. And we have a raised hand. I don't know. I think it's Andy Van Niekerk. Hold on a second. Did you want to turn on your mic, Andy, or? I don't know. I don't see him. Or offer something in the chat. I just want to thank all of our panelists and speakers today. I really appreciate your work and expertise and the commitment that you have made to help farmers adapt and adopt best management practices. I am going to, Jonathan, if you don't mind stopping your share, because I'm going to share my screen and put up the KSE
yeah, we're
code.
just trying to figure out where to find that. I don't use Zoom as much as Teams, unfortunately.
I think a lot of people are like that these days. Okay, I'm going to put up the knowledge sharing event QR code for anybody here that is collecting credits for your off-calf KSCs. Let me just put that in there. And this is sort of bringing us to the end of the forum. As we wrap up today's forum, one thing's clear. Managing nutrients and protecting water quality isn't about a single practice or tool. It's about understanding systems, making informed decisions, and learning together over time. From nutrient pathways and edge of field research to 4R management, soil health monitoring, and emerging tools like SWOT Water, today's session highlights how strong science, practical innovation, and farmer leadership come together on the ground. Most importantly, this work only matters because it's rooted in real farms and real decisions. Thanks again to our presenters, the Conservation Authority partners, agronomists, and especially our farm cooperators for sharing your expertise and insights today. Your willingness to test, measure, adapt, and share is what drives progress across this province. We appreciate everyone for taking the time to be part of the conversation today, and we look forward to building on these learnings as On-Farm continues. Thanks for your commitment to improving both farm productivity and environmental outcomes. We will share the video up on the On-Farm website. I've put the address in the chat. And with that, that is the end of our On-Farm 2026 forum. Thank you, everybody, for joining us. It was a great, great day.
Thanks.